Well, welcome back, everybody. I hope everybody had a good break, perhaps an opportunity to go grab another coffee, what have you. We are going to be starting our fourth session of the Vahouny Fiber Symposium. And as we get started, I'd like to ask Dr. George Fahey and Dr. Joanne Slavin to join real quick on the screen and just briefly introduce yourself, and then we will queue up the first presentation.
Good day, everybody. My name is George Fahey from the University of Illinois at Urbana-Champaign.
Hi, this is Joanne Slavin. I'm at the Department of Food Science and Nutrition, University of Minnesota, and happy to be one of the moderators with Dr. Fahey for this session.
Excellent. So we're going to play the first recorded video, and as we have done, please be viewing it and knowing that we will be we will be looking at questions that you all are typing in. So with that,
Good morning, everybody. Welcome to this session entitled Standardized Protocol for Evaluating Digestive Tolerance of Non-Digestible Carbohydrates Among the General Population. My name is George Fahey. I'll be the session chair for this particular symposium that's being held at the 12th Vahouny Fiber Symposium. By way of disclosures, I am at the University of Illinois. I'm a professor emeritus of animal sciences and also the Kraft Foods Endowed Professor Emeritus of Nutritional Sciences. I retired in 2010 and actually conducted research until 2016 when I turned over the lab to others. And I still do some work there. I do a little publishing. I serve on graduate committees and do some special projects. Most of my time is spent in my business, Fahey Nutrition Consulting, where I'm the owner of that particular enterprise. About 75% of what I do has to do with the pet food industry, where I am a consultant to the industry, to the ingredient suppliers, to marketing agencies that support the pet industry. About 30% or so of my time is spent on human nutrition related matters, especially GRAS expert panels, where I've been involved with many of those. For ILSI, I've been the advisor to the Carbohydrate Committee for quite a few years. So let's talk about non-digestible carbohydrates for just a second. I prefer to call them low digestible carbohydrates. But the definition is that they are carbohydrates that are incompletely digested in the small intestine, but are at least partially fermented by the microbiota in the large intestine. There are several types of non-digestible carbohydrates. They are dietary fibers, the many that exist, resistant starches, sugar alcohols. Those would be the three main categories. The reason that we're interested in these is that they've been shown to have health benefits, reduce calories, they modulate blood glucose concentration, they modulate blood cholesterol concentration, they're non-cariogenic, they have properties that impact in a positive way laxation, satiety, mineral absorption, etc. So because of those health benefits, then their presence in food matrices is increasing. But then there is the matter of tolerance. Tolerance can be an issue for certain people. Now, what determines tolerance to non-digestible carbohydrates? Well, there are quite a few things. One is the specific fiber or sugar alcohol or polyol, or the resistant starch type. All of these impact tolerance. The concentration of the NDC in the food product that's ingested, the amount of the food product ingested that has the NDC in it, the frequency of ingestion of the food product. Other foods will also impact how tolerable the non-digestible carbohydrates are, whether we consume a lot of liquid or not so much. is a factor. And then not all of us have the same exact digestive physiology, so the individual ingesting the food can make a big difference. So quite a few factors impact this, and the complication is the interaction that occurs among these factors. And that makes it very difficult to predict tolerance to numerous NDCs that are available today. Now, the two main challenges that exist, there is no definition for tolerance as applied to non-digestible carbohydrates, making a standard protocol all the more important. And the second challenge is that for NDCs that are not yet considered fibers, tolerance is not an accepted benefit for fiber by the FDA. Thus, incorporating other measures that are currently accepted, like laxation, may be indicated. So the purpose of our session today is that we would like to see developed a tool that can be used by clinical trial organizations, funding organizations, and consumer product manufacturers to assess digestive tolerance to NDCs for decision making when incorporating those NDCs into food products for consumption by adults and by children. There are 5 topics that will be covered by 5 different experts. We want to get feedback from the attendees. That's welcomed, and in point of fact, it's necessary to make this protocol as good as it can be. And what will happen is that these experts, after receiving all the input, will write a protocol that will harmonize GI tolerance testing for adults and children. And this protocol will be published in a high-quality refereed journal. So the different topics are here, starting out with an overview of the proposed protocol, its purpose, applications to food formulation, decision-making, key principles, intervention product and control product, ingredient, finished product format, matrix, what's the dose, dietary reporting needs, length of treatment, compliance. Those issues will be discussed in another talk. Then we have a talk about the population, the selection criteria, special considerations for different populations. A 4th talk will be on the outcomes, what tests are needed to measure the relevant outcomes that assess tolerance in the best way possible. And then finally, we'll end with special considerations for GI tolerance testing in children, differences between children and adults, symptom assessment, etc. And the speakers that you'll hear are Hannah Hosher from the University of Illinois at Urbana, Wendy Dahl from the University of Florida at Gainesville, Deanne Liska at Texas A&M in College Station, Kristen Verbecki from Leuven in Belgium, and then Dr. Bruno Champatazzi from the Baylor College of Medicine, Houston, Texas. So we're looking forward to a good program, and we'll be hearing from all of these experts as regards this issue. Thank you very much. Okay, are we back on?
We can hear you. Thanks, George.
Okay, thanks. Well, hello again, and we're going to move right into the first speaker here, Hannah Hosher, who's going to talk about designing a protocol to evaluate tolerance of NDCs. So, Hannah, it's all yours.
Thank you for joining us. My name is Hannah Holscher, and I'm going to be discussing considerations for designing a protocol to evaluate tolerance of non-digestible carbohydrates. On this slide, I've presented my disclosures over the last 2 years. These include grants from food boards, private industry, and government organizations. My role as an advisor on the Grains Food Foundation Scientific Advisory Board and speaking honorarium that I've received from several companies. Let's begin with some definitions. As we're discussing tolerance as it relates to non-digestible carbohydrates, which I'll abbreviate as INDC throughout this presentation, it's important to consider what these are and their effects throughout the body. So firstly, these are carbohydrates that are incompletely digested or not absorbed within the small intestine, and then they're partially to completely fermented within the large intestine. So the schematic you'll see on the right, I've called out the colon where this fermentation is going to be occurring. Approximately 40 grams of carbohydrates each day will escape digestion and can certainly be fermented by the microbiota. And then the other categories of non-digestible carbohydrates that we'll be focusing on for this protocol and this presentation specifically will be fibers and resistant starch. Dietary fiber is a regulated term. It is found on the nutrition facts label. And according to the 2017 final ruling definition by the Food and Drug Administration, dietary fiber are non-digestible, soluble, and insoluble carbohydrates and lignin that are intrinsic and intact within plants, as well as isolated or synthetic non-digestible carbohydrates determined by FDA to have physiological effects that are beneficial to human health. So what are these physiological benefits to human health as they relate to fiber? Well, there are a range of them, and some of those examples that have been evaluated by FDA include lowering blood glucose, lowering cholesterol levels, increasing calcium, reducing energy intake, and certainly increasing frequency of bowel movements or improving laxation. And based on these physiological benefits, a number of different fibers that have been tested in clinical trials have been shown to have benefits and are subsequently accepted as dietary fibers. These include arabinoxylan and alginate for blood glucose, several gums and pectin for cholesterol lowering, calcium absorption, different inulin and inulin-type fructans, galactoligosaccharides, and resistant maltodextrin are going to fall within the category as having a benefit on increasing calcium absorption within the intestine. Polydextrose has been shown to contribute to reduced energy intake, and then cellulose has a demonstrated benefit for increasing frequency of bowel movements or improving laxation. I should note that this list is not all-inclusive. This isn't all of the isolated and synthetic fibers that have been shown to have a physiological benefit, but it does include most of them. So where do we find these non-digestible carbohydrates and what are their purposes? So again, non-digestible carbohydrates can certainly be intrinsic and intact within foods like fruits, vegetables, whole grains, nuts, and legumes, but they're increasingly added into food products for a number of reasons. Some of those foods are listed on the left: bars, cereals, ice cream, juices, yogurt. And again, this is not an all-inclusive list, but you can see this is a diverse array of processed foods. And the reason these fibers or non-digestible carbohydrates are added range. They would certainly include increasing the fiber content. Certain non-digestible carbohydrates can serve as sugar replacers. So fructooligosaccharides contribute a sweetness that allows for reduced sugar content in the product. Inulin can serve as a fat replacer. It helps contribute to that creamy mouthfeel and allows the manufacturer to reduce the fat content within the product. Gums can contribute to thickening, and certain other fibers like polydextrose may be useful as a bulking agent. So there are certainly functions of these fibers from a food science and a food preparation perspective. But the other really important component is that there are health benefits by adding specific fibers to foods. So with that background, let's move on to more of a focus on tolerance. Firstly, as we consider tolerance, we have to consider that non-digestible carbohydrates are very heterogeneous, and different fibers are going to have different effects on tolerance. And so some of the characteristics that are related to the heterogeneity of different non-digestible carbohydrates include their origin, the molecular composition, which would include the monosaccharides that make up the molecule, the linkages, that connect them and the degrees of polymerization. The other characteristics of fibers would include their physicochemical properties, including their solubility, viscosity, and certainly the fermentability. These physicochemical properties are also going to underlie some of the health benefits. Ultimately, what we want to stress here is that non-digestible carbohydrates are heterogeneous, and that needs to be considered in the development of protocols and subsequent testing and incorporation within foods. There are also personal characteristics that are going to influence tolerance as well, though. Interindividual differences, and there's a range of these, and there'll be a spectrum within each. So factors such as age, sex, health status, diet, physical activity, medications, genetics, and the microbiota can all influence an individual's tolerance to a specific fiber. Focusing in just a little bit more on an example of the characteristics of non-digestible carbohydrates and why they are important to consider for tolerance include the physicochemical properties. So I've mentioned that solubility, viscosity, and fermentability are physicochemical properties of non-digestible carbohydrates. And so for solubility, we're considering the ability to dissolve in water as opposed to remaining as discrete particles. Viscosity is that thickening and gel forming characteristic where fermentability is going to really hone in on, after resisting digestion, how is this fiber, non-digestible carbohydrate metabolized by microbes. And again, we care about these characteristics because they'll influence the health outcomes as well as tolerance. So for an example of an insoluble non-digestible carbohydrate, cellulose is going to contribute a laxative effect. Soluble viscous non-fermented fibers have been shown to have cholesterol-lowering effects, improving glycemia, contribute to weight loss, and stool normalization. Alternatively, when we consider soluble non-viscous fermentable fibers like inulin-type fructans, these fibers can reduce inflammation, help facilitate weight loss, and increase calcium absorption within the intestine. And then another category to consider are the soluble viscous fermentable fibers. That would include fibers such as pectin and beta-glucan, which have been shown to have health benefits, including cholesterol lowering and improved glycemia. So when we consider non-digestible carbohydrates as a group as a whole, again, they're going to contribute a lot of different health benefits. So as we think a bit more about fermentation, we're of course acknowledging that microbial fermentation of non-digestible carbohydrate results in short-chain fatty acid and gas production. These gases include carbon dioxide, hydrogen, and methane. And this gas production is going to play a role in tolerance because of its contributions to outcomes including abdominal distension and flatulence. So again, thinking about fermentation and tolerance, we can hone in on the gut and consider gastrointestinal outcomes, including belching, nausea, bloating, flatulence, as well as stool form and frequency. But we know that the gut does not operate in isolation, especially if we acknowledge the complexity of the gut-brain axis and the bidirectional communication that occurs. So there may also be interest and a need to assess extra gastrointestinal outcomes. Factors including appetite or satiety, headache, mood, quality of life. Different factors may have more relevance in certain populations than others, but are certainly part of the conversation and considerations. So let's move into the last portion of my presentation, where I want to allude to the process of the protocol development and discuss a little bit about the different challenges and considerations that are going to be involved in this process. One of the first challenges, and also an important consideration, is that there isn't a true and regulated definition of tolerance. Considering that gray area in the conversation is going to be important as we decide what are the most salient factors that need to be considered and measured. We also need to discuss that there are both primary and secondary objectives and outcomes involved when different trials are conducted. Tolerance is certainly an area of interest, and so when it is the focus of a trial or a primary outcome of the trial, the design of that trial is very likely to be different than if it's a secondary outcome. For example, if we have a fiber intervention where we're looking at the efficacy of that fiber on weight loss, tolerance should be included as a secondary outcome, but the duration of that study and the design of the study is going to rely on the primary outcome. We need to have an iterative process here as we consider the study design to ensure that the design allows for the answer to the research question and to meet the primary and secondary objectives and to be able to measure the outcomes within the trial. Some of the other considerations that we'll be discussing today include the participants. What are the considerations for the participants? Who are these individuals that are in the study? What should that look like? And then certainly, of course, making sure that all of that information is properly documented. Considerations for the intervention. What is provided? And there is a lot to be considered within this context as well. And my colleague, Dr. Dahl, will be providing a comprehensive overview of that topic. But it would certainly include things like dose, frequency, food matrix as some examples. What is the control? Well, ultimately, this depends on the objective of the study. What is the primary outcome? What is a secondary outcome? And so there may need to be considerations for both a positive and a negative control depending on the question. And then outcomes. What should be measured? What are some of the strengths and limitations of these different measures? And how can we create a comprehensive set of measures that again allow us to assess tolerance as well as the other outcomes of interest within that trial. When we consider study designs for experimental studies or trials, the randomized double-blind placebo-controlled trial is going to remain the gold standard. So the highest level of evidence here, thinking back to the previous points, that design is going to be based on the objectives and the hypothesis of the study. And so whether the trial can be a crossover as opposed to a parallel arm will depend on that primary outcome. How long does it take to arrive at that primary outcome? For tolerance, we may be looking at a shorter design. 24, 48 hours may be adequate to assess that. However, if we're looking at weight loss or glycemic control, longer trials of upwards of 3 months may be indicated. And so these primary outcomes are going to drive the duration of the treatment. And again, this is an iterative process because depending on the duration of that treatment, it may or may not be feasible to do a crossover design. If you have a 12-week intervention, the washout may need to be just as long as that intervention. So we have a 12, 24, 36-week study to be able to assess our outcomes. That can be quite difficult. So again, considering the primary outcome, utilizing a crossover versus a parallel arm is going to be an important consideration. Some trials may not be ethical or feasible, and so in these cases, an observational study would be indicated. But for considering observational studies, these would need to be longitudinal and making sure that there's both an assessment of the exposure as well as confounding as it relates to those personal characteristics, right? Diet, medications, microbiome, for example. So we've just been discussing some of the study design characteristics as we are considering protocol design considerations. And then the next presentations are going to do a deeper dive on others, including the population, what individuals should be enrolled in these trials, what should be your inclusion and exclusion criteria, because again, we realize that for a trial that's based on safety, that inclusion and exclusion criteria is going to be much more stringent. However, as we think about the consumers, their characteristics are going to be much more heterogeneous. And so enrolling a more heterogeneous population may be necessary to answer your research question. The intervention. What is the dose? What is the frequency? What is the form? All of these factors will need to be considered in designing the trial and then measuring the outcomes. Utilizing the appropriate comparator, the controls or the placebos. Potentially the inclusion of both a positive and a negative control may be indicated. And then certainly the outcomes. What measures are absolutely imperative so that we can adequately assess tolerance? What measures may just be considered to be exploratory as opposed to standard? And what are the strengths and limitations of each of these outcomes? So again, my colleagues will be able to provide a much more comprehensive discussion around these topics. These conversations, the development of a protocol, have a number of stakeholders that will be impacted. And so this is a conversation and an iterative process as we consider the implications. Certainly, industry has been involved in the isolation or synthesis of these non-digestible carbohydrates. They've already undergone, we can presume, safety testing. And so now as we consider these tolerance and efficacy type trials, these conversations are going to be primarily between scientists within academia, government, and industry, so that trials can be designed and outcomes can be assessed to answer the research questions. So at the end of the day, these different non-digestible carbohydrates within the food system are going to be provided to customers that span the lifespan and will have different needs and considerations. And these different customers will also be in communication with healthcare providers. Depending on their health status, certain clinicians, registered dietitians, medical practitioners, gastroenterologists may be recommending certain food products to help improve their gastrointestinal health, for example, relaxation. And so again, the role of tolerance and being able to test that is going to inform these recommendations. Then this certainly wraps back around to marketing. How do individuals even know about these products so that they can consume them and hopefully be able to obtain those health benefits that are associated? I hope from this presentation you've been able to appreciate that consumption of non-digestible carbohydrates affects tolerance, and this is something that's important to measure. However, there are many considerations as well as challenges that need to be considered when designing a protocol. And this is not going to be done within a vacuum. There are implications for stakeholders. And so I look forward to a rich dialogue around this topic. Thank you for your time and attention.
Okay, Hannah, thanks very much for that great overview. Hannah's already on here with us, and we have time for some clarifying questions, and we have a couple that have been submitted here. So let me take a look at those. You're also free to write questions as the presenter is actually giving the talk, so that your question will get answered. So let's just look here at one question has to do, it says, it seems the definition of tolerance may be the biggest hurdle in this exercise. Since all the GI effects you described are considered normal, how do you decide when there are enough differences to be abnormal to consuming NDC?
Yeah, thank you for that astute question. And you've definitely, acknowledged one of the hurdles that we see, and one of the considerations that we have been, considering as we talk about the different outcomes that need to be measured, including adverse effects versus what needs to be assessed, and also the population. So again, thinking about this range of healthy versus disease when we consider healthy versus irritable bowel syndrome, for example, or healthy within the spectrum of overweight and obesity. So I think that's an excellent question, and we should slate that also for back at our discussion that will occur after all of the presentations, because my hope is that, again, this will be a rich dialogue, and after you all have heard from Dr. Dahl about the interventions, Dr. Liska for the populations, Dr. Verbecki for outcomes, and then Dr. Champanaza, he's going to be able to bring in that clinical gastroenterologist perspective and hone in a little bit more about these tolerance questions. So I think their insight is all going to be imperative so that we can properly discuss that tolerance question.
Okay, thank you.
I was hoping, George, I could jump in and say thanks to the group and to Hannah for focusing on this topic, because for someone who's been in fiber for 50 years why don't people eat more fiber? Because of tolerance. It just always comes up, and it's never going to be the primary objective in a study. It's always later we go back and look and say, hey, did we get that covered? And we typically don't get it covered because we aren't thinking about it. So I think this is a wonderful topic, and I appreciate bringing all these experts together to get to the bottom of this and come up with better protocols to get people to eat more fiber, because we still have this huge problem after 50 years of, the fiber got rediscovered in the early 70s. Why don't we eat as much fiber as we're supposed to? And tolerance is the number one thing. So really appreciate having this session.
Yeah,
Thanks.
great comment, Joanne. Thanks. Another question has to do with fermentability. You mentioned that as one of the 3 criteria. This person says, I think the rate of fermentation plays an important role on tolerability, the rate of fermentation. Do you have any comment on that?
For that, I think it would be important to listen to Dr. Verbecki talk about some of the outcomes, because she will be discussing a range of different assessment measures that, as well as Dr. Dahl, who will be talking about considerations for different fibers. So again, I think that's a really great and important question, because we know the microbiome varies throughout the gastrointestinal tract. We know that the degrees of polymerization for these fibers is going to vary, and that's going to influence the rate of fermentation. And so definitely something we've been considering and discussing, and we should slate that back in to return to in the group discussion after the other presenters.
Okay. Is there a need to give at least a comment about tolerance by individuals with some disease, or are you going to focus on the healthy population, or is it going to be people, health compromised people, or have you got to that discussion?
Yeah, again, I love that everyone is thinking about all these really important topics. And so Dr. Liska is going to go into some more detail about that range and that spectrum of healthy, and also allude to, one of those challenges is going to be, again, when do we get to that definition of something like irritable bowel syndrome, and how many people are self-diagnosing versus actually diagnosed by a physician? And so she'll go into some more detail about considerations for those populations.
Okay. One of the challenges will be, if you go by that grouping that I gave, I think the work on sugar alcohols will be straightforward. I think the work on resistant starches will be straightforward. But then you get into that whole group of fibers, like you mentioned, how heterogeneous they are. So I'm wondering how you even start with that. You can't do every one. There are so many. Do you talk about insoluble dietary fibers versus soluble? Have you given any thought about breaking that down into something manageable so that fibers themselves, the intrinsic and intact, or the synthetic, or the isolated, can be discussed and tolerability assessed?
Yeah, those are really great questions. I think one of the things that we have to acknowledge is, because of that range, this group has primarily been focusing on fibers and resistant starch, and acknowledging the importance of sugar alcohols, but have left those a bit by the wayside, and they won't actually be specifically encompassed within this protocol. And I think you'll see from the next presentations on those interventions and the considerations for different types of fibers, that can the interventions and the comparators, you'll see a bit more discussion about our considerations and thought processes around that. But ultimately, as we consider development of a protocol, I think this is going to be a little bit more of a gray protocol than, a sheet of paper that we're going to hand out for anyone that wants to do tolerance. We're going to make recommendations based on the scientific literature and the experts' opinions today, as well as the experts that are in the audience. Because what you'll note from our scientific experts that are presenting is we span a breadth of expertise in academia and clinical practice, but what we don't have included is as much of the perspective from an industry angle. And so again, we're going to want to have this iterative discussion when we get to the end of the presentations to make sure that some of these important points are not missed, and so that we can incorporate those in the manuscript for recommendations and considerations when individuals go forward to do their clinical trials.
Okay, good. Somebody just makes a point here. It's not a question really, but they said to keep in mind about adaptation to the fiber diet. They believe that's an important aspect of this. So that's just a discussion point. And let me see if there's another one here. Yeah, I think that's about it. Okay, well, you've set up all your colleagues very well. And so I think I don't see any more burning questions here. So I think we'll move out a little bit early. We have permission to do that and give everybody else a minute or two. So now we would go on to Wendy for her presentation. Wendy's from the University, Wendy Dahl from the University of Florida will give the next presentation.
Great, thank you.
Hello, everyone. Today I'll be highlighting food product considerations for tolerance testing, including the levels tested, food form, control product choices, intake timing, and background dietary intake considerations. So first, my disclosures. I've received funding from Lallemande Health Solutions, Bioingredients, NIH, Borlaug Higher Education Grants, and the USDA, and paid travel from Dietitians of Canada and Lallemande Health Solutions. So non-digestible carbohydrates comprise a wide range of natural occurring and synthetic or modified food ingredients. From a recent review on fiber specifically, this figure shows how properties impact their functionality, which in turn affects the physiological response. And one of those responses is tolerance. And of course, the physiology then impacts their health benefits. First and foremost, our consideration when planning tolerance testing is fully characterizing the non-digestible carbohydrate of interest. So many studies have been published that simply have not adequately described the fiber-resistant starch that's been tested, making it very difficult to compare the results to other studies. So for transparent reporting, to provide enough information for study replication, and to compare the results of tolerance studies, we need details of composition. We need its structure, such as the composite sugars and the linkages, the particle size of the product, and its functionality, such as viscosity and fermentability. Reporting the quantity of the non-digestible carbohydrate administered is, of course, critical, particularly the fraction of the dose that is in fact non-digestible. It's also needed. Now let's consider the dose, the quantity that's administered in a little bit more detail. So what is well known is that tolerance, specifically gastrointestinal tolerance to non-digestible carbohydrate intake, varies considerably with dose, the amount consumed. This is dependent in part by the speed and extent of fermentation by the gut microbes, specifically when we are assessing those lower GI symptoms such as gas and bloating. And so from a review a few years back, we can see that the dose tolerance to inulin, fructan, is considered to be acceptable or well tolerated up to about 15 or so grams a day. In contrast, the acceptable level of resistant starches, at least those included in this review, are much higher, as is polydextrose. So reported symptoms and symptom intensity typically increase with dose, unless perhaps the non-digestible carbohydrate is completely resistant to fermentation. So as an example, the figure on the right shows the average weekly GI symptom intensity scores during an 8-week study. The study was designed to test the effect of foods with added oligofructose on energy intake and stool frequency in healthy young adults, and the GI symptoms were monitored as a secondary outcome. So 2 foods a day, a snack bar and yogurt, each with 8 grams of added oligofructose were provided. An online dietary questionnaire was used to rate bloating, flatulence, abdominal discomfort, and abdominal noises. So we can see here from the symptom intensity that at the first week, when 8 grams of oligofructose was provided, there's an increase in symptoms. You can see with the ones, the open circle and the open triangle, where there's an increase in symptoms. And then at week 2, when 16 grams of oligofructose was given, the symptoms further increase. However, it's statistically significant, but is it intolerance? Symptom intensity jumped about 2 points on a scale of 24. So that is something to think about. So we're proposing a goal to harmonize testing levels or doses to allow comparisons of non-digestible carbohydrate ingredients. So industry can compare alternative ingredients based on the consumer's GI tolerance. And so for lower doses, given that the US daily value for fiber is 28 grams a day, 10% of the DV is 2.8 grams per serving, and that of course can be labeled as a good source of and 20% of the DV, or 5.6 grams per serving, is an excellent source of fiber. So these levels are definitely recommended for inclusion in any dose response tolerance testing. And so for the Canadian market, source, high source, and very high source can be made for foods containing a minimum of 2, 4, or 6 grams of dietary fiber per serving. As 2 grams would not be expected to elicit a measurable tolerance issue in healthy adults, testing levels of 4 and 6 would be appropriate if we wanted to align the US and the Canadian levels. But if we were only interested in the US market alone, we could test 3 and 6 grams per serving. So one limitation to setting doses for testing using the percent DV is that the levels will be independent of energy intake of individuals. And even though, our adequate intake for fiber is based on energy intake. So the addition of 3 grams of fiber to the diet of a 21-year-old male athlete consuming perhaps in excess of 3,000 calories per day may not elicit the same response as a 60-year-old female at 1,500 kilocalories per day. So we'll hear more about population challenges in the presentation to follow. So let's consider an additional level that we might want to test if tolerance is being tested as a secondary outcome in an efficacy study. So we really want to come up with a figure that would be a total daily intake that we would test in a tolerance study. So let's first look at viscous fibers. Viscous fibers have been frequently tested for cardiometabolic outcomes such as cholesterol and glucose levels. If we consider the meta-analysis data on, for example, psyllium or viscous fibers in general, it provides us with some information on a potential daily level that could be tested. So in 3 studies, providing 7 to 15 grams of psyllium for cholesterol lowering in addition to statins, so that gives us one range. A medium dose of about 13 grams of viscous fiber significantly reduced hemoglobin A1C, fasting blood glucose, and insulin resistance. And in another meta-analysis, 8.7 grams per day was effective for blood pressure lowering. So these studies suggest that perhaps 10 or 15 grams per day could be tested for efficacy and also at the same time for tolerance. Of course, splitting the dose with meals would improve the tolerance and likely the efficacy also. So just a comment about, really how high should we go in terms of testing in food products. Well, acceptability of the food product really limits the highest dose that could be tested, especially for viscous fibers. So here's an example of 23 grams of psyllium blunting the glucose response in healthy young adults. It's highly effective, but if you see in the graph below, so you can see the blunting here of the glucose response, but if you see the graph below, the actual desire to eat that food really drops off. And so one would also wonder about the tolerance of this dose. So the level of a non-digestible carbohydrate tested needs to be realistic to be able to be incorporated into an acceptable food product. So testing tolerance at a daily amount may not be needed, as usually the amount for a health claim is the total daily amount to achieve the health outcome divided by 4 servings per day. So let's now consider setting a daily dose to test tolerance as a secondary outcome in a laxation study. So the goal would be to test tolerance while also demonstrating a meaningful change in stool frequency or transit time in a healthy population. As figure 1 shows, increased fecal weight is really easily demonstrated, even with a small sample size in a highly controlled study, when a fiber is resistant to fermentation. But at least in this study, the young, healthy males show no changes in transit time or stool frequencies, because these are really difficult outcomes to show unless individuals have some level of infrequency suggestive of constipation, and those individuals are included in the testing population. So, but if we consider studies of those individuals exhibiting constipation, about 5 to 15 grams of non-digestible carbohydrate has shown efficacy for relief. So in the second figure, it gives an example of a highly fermentable fiber and its effect on stool frequency. So 25 participants per group were needed to show a significant increase, with 16 grams of oligofructose per day. A more detailed review of the evidence really is needed, but a total daily dose for tolerance testing in a healthy population when the primary outcome is laxation might need to be about 15 grams per day, similar to the viscosity recommendation. And this dose is, of course, best divided into 2 to 3 servings a day. So another consideration for tolerance testing is the form of the food or the food vehicle. The choice for an insoluble ingredient is often limited to a solid food based on acceptability. An excellent source food product is achievable in a baked product. For soluble fibers, either solid, semi-solid, or liquid food products are achievable. Does the food form actually affect tolerance? So if a difference is seen in tolerance, it may be due to changes in gastric emptying that will affect how quickly that full dose of fiber gets to the colon and begins to be fermented. We can see in the figures shown that solids remain in the stomach longer than liquids, and high calorie liquids remain longer than low calorie liquids or water. You can see also that they indicated indigestible solids remain in the stomach for longer periods of time, but see that these are very large particles, 5 to 7 millimeters in size, and so those would not be comparable to the size of particles, of course, that we would see with non-digestible carbohydrates, which are very small. Those particles, actually 5 to 7 millimeters in size, are larger than most food particles that we swallow after mastication. So definitely there's a possibility that food form influences tolerance. So really the most important consideration for food form when you're testing for tolerance is to ensure that the intervention food product that contains that non-digestible carbohydrate and the control food comparator are as similar in form as possible, especially viscosity, because we know that viscosity affects gastric emptying. So what should be used as a control in a study assessing tolerance to a non-digestible carbohydrate ingredient? A negative control is a must, and that would be a food product that is as similar as possible to the intervention product, but of course with no non-digestible carbohydrate ingredient. However, to provide industry with more information to compare those non-digestible carbohydrate ingredients, I would suggest considering a positive control. And so this would be a food product, again, that is similar to the intervention food, but with a well-known non-digestible carbohydrate added at a similar level to the intervention product. What might be some suggested positive comparators? Well, if testing a viscous fiber, so much is known about psyllium, so this may be an appropriate choice. For non-digestible carbohydrates, that's being tested for laxation efficacy. The choice of a positive control may actually depend on whether the product you want to test is fermentable. If it's not fermentable, you may want to choose a positive control that is resistant, that's known to be resistant to fermentation. If the product that you want to test is highly fermentable, you may then want to choose a positive control that's highly fermentable, that's been previously tested. The guidance that we have from FDA is simply an appropriate control for the primary outcome. So characterizing the fermentability of your product with in vitro testing may actually help with the choice of what positive control should be used. And as there really are some misconceptions out there in terms of the fermentability of various non-digestible carbohydrates. A good example being dietary cellulose, that's often mentioned as being non-fermentable when actually it is highly fermentable. So what about the timing of intake of non-digestible containing food? Recommendations for acute, like for instance, 1 meal studies, outlining the length of fasting, intake time, the consistency of meals, may best mirror perhaps the best practices that are used for instance, glycemic response studies. For longer studies, such as laxation studies, which typically last greater than a week, cholesterol lowering, which need to be more than 3 weeks, immunity, greater than 8 weeks, we should consider the impact of when the food product is consumed. Is it consumed morning or evening? Because this may affect tolerance reporting, because symptoms may go unnoticed if it's consumed later in the day. We also should consider, for instance, differing transit time on tolerance outcomes. And so this is primarily large intestinal transit time. So we might expect, for instance, little fermentation and thus no symptoms when we have participants with a transit time of less than 24 hours, but possibly more extensive fermentation and symptoms with individuals with transit time of greater than 72 hours, which these transit times are common in the healthy population. So compliance is another issue to consider, because compliance to consuming the intervention food products does become a major issue with these longer trials. But it is so difficult for us to ensure that we have compliance, as there's really no objective marker to measure compliance, just participant reporting. So another consideration is tolerance influenced by microbiota composition? Well, we recently carried out a randomized crossover trial studying PICO fiber on various outcomes, including gastrointestinal symptoms. And those were looked at weekly using the gastrointestinal response scale. We found that 7 of the participants showed a marked increase in flatulence with the PICO fiber, while 22 of the participants, the rest of the participants, showed little or no response. And so I thought that was curious. And so a comparison of their microbiota composition showed that these individuals that reported high levels of flatulence, which we labeled as fermenters, exhibited a higher relative proportion of methanogens and methane producers. And so microbiota baseline composition might be another factor that we need to consider in these tolerance studies. So tight dietary control using full feeding protocols can ensure high sensitivity for tolerance testing, meaning that we will be able to pick up on these symptoms if we control the background diet. So in this example, it's a multiple crossover study where 5 grams of inulin, the prebiotic, resulted in a significant increase in indigestion, including symptoms of stomach rumbling, bloating, burping, and flatulence. We might not have demonstrated this finding if we had not controlled for diet. So that's another consideration. However, these full feeding trials are, of course, very expensive. So perhaps tolerance might be best tested with the consumption of usual diets versus controlled diets anyways, similar to how the food product will be consumed by the consumer. Our tendency to be resistant to dietary change is actually helpful. It's not helpful when people are trying to lose weight, but it is helpful when we want our participants in this study to keep their dietary intake fairly constant. But we do need to have detailed information on dietary intake, including the background intake of fiber, especially to allow comparisons between the control and the non-digestible carbohydrate intervention group or period. We know that dietary intake may modulate the microbiota composition through fermentation, and thus also gas production, but also possibly the visceral sensitivity, how much that individuals really can feel the presence of gas, and so will contribute to the symptoms. And the longer the study, the more this may be a factor. So a controlled diet may help to control for the effect of the background diet, but it in itself may also impact the microbiota composition of the participants. And so a run-in period of the study diet may be needed. So in summary, the considerations that we need to make for food products and controls, we first need to fully characterize the non-digestible carbohydrate of interest. Next, we have to decide on the level per serving or the dose testing, and we recommend that we should test at source and excellent source levels, and proposing perhaps a 15 gram per day total split dose if tolerance is a secondary outcome of an efficacy study. Using a consistent food form, ensuring that the intervention food is similar, very similar to the control food. Consider perhaps a positive control or comparator in addition to what we usually use, a negative control. So finally, and conduct precision dietary intake and compliance monitoring.
Okay, very good. Thanks so much, Wendy. It was a great presentation. Wendy has joined us here, and so I think Joanne will take the look at the question box and see what's going on. You're muted, Joanne.
How about now?
Perfect.
Excellent. Hey, wonderful presentation, Wendy. Lots of questions. So since I get a little bit of the time to come in here, I really appreciate all the new people that have gotten into fiber and interested in fiber. And I want to give a shout out as somebody who's been at all the Vahouny fiber symposiums before. Dr. Klerfeld did a nice example of who's been involved, but I really want to highlight my advisor, Dr. Judy Marlette, who took me on long ago as a student. So when I see some former students, other students that are here, and Dr. Cho, who worked with me in Dr. Marlette's lab. So it's really nice to see new people coming into the field, but I really want to talk to the pioneers. A lot of them have been involved forever, but some of them have left us, are no longer in the field. And the reason I kind of spin this yarn is because one of the questions had to do with, does transit time get slower with age? And so much of what I always tell my students, we say, oh, if it hasn't been done in the last 5 years, it doesn't matter. There's so much that's known. So one of the studies we did long ago with Dr. Marlette, looking at older versus younger people and changes in transit time, and we couldn't document that there was any change with age per se. So that was one of the questions that was asked to you, Wendy. How do you feel about changes in transit time with age and age of participants in a study? Do you think there's a reason to be concerned about that?
Well, it's definitely something that we should think about, but I would agree with you, Joanne, that these are things that we hear all the time. We hear that, you know, transit time decreases with age. We also now hear that, of course, that the microbiota composition is so terrible in older adults, and that's, of course, not the case. If you actually look at a microbiota composition of healthy older adults, it actually, some of them have profiles similar to 18-year-olds. So yeah, it's just one of those things that we've continued to talk about. I think it is something that we do have to look at more and more, though, because like, for instance, in the spring, we ran a study and we actually recruited only people who had daily bowel movements. So we've thought that, you know, that these are not constipated individuals. These are people, you know, daily bowel movements, you know, right on time, that sort of thing. And we did transit time testing on these individuals, and the transit time varied from 21 hours to over 80 hours.
Wow.
Yeah, and so, and especially when we're looking at shorter studies, yeah, we really need to start considering transit time more and more, I think.
Yeah,
I don't know if I answered your question, Joanne, but.
Absolutely, and all of us that have done that know how challenging it is to get transit time measures, and that's a whole nother ballgame. But another question that came up that I think is important is that if you're doing a study and gastric emptying affects your tolerance, should you control all the liquids that people consume besides your treatment? So you did a great job of explaining and detailing how difficult it is to decide this is going to be my intervention. We're going to give it to you in a muffin. We're going to give it to you in some kind of food. We're going to try to come up with a control or a placebo. But do you have to not let them have water? That was one of the questions one of the participant or one of the people asked about. Do you control that completely? Should that be standardized, or how do you feel about that?
Well, we have not controlled for that, but the vast majority of studies that we've carried out are longer term trials. And so for the shorter term trials, yes, you definitely want to control for that. If you're looking at, you know, post-meal effects or 24-hour effects, yes, I would control for that. But with our longer ones, our goal is for them to consume that fiber containing, you know, food, good compliance. We want to see good compliance, but we do not control for those, the timing and what else they're consuming with that food.
There are some other questions, just have to, like, picking your sample. There are people that are obviously very intolerant to carbohydrates, right? And those people, you know, are they constipated? Do they have diarrhea? I mean, are they diseased? Are they healthy? It's really hard to do these studies. And I know Hannah got the question too, why are you starting in normal subjects? Because I think we need to get these protocols figured out in normal subjects before they have a disease or so absolutely, I think that's important. But how do you figure out your sample size then when you have so much variability that certain people, like in your study with your controlled diets, certain people were quite sensitive to the inulin and everything else in the diet was controlled, right? So you have to assume that that response you saw had to do with the fiber itself.
Yeah, we definitely were able to, like, it was sensitive enough to be able to pick up an increase in the symptoms. But one of the things, though, that we didn't see is an intolerance. Like, we didn't have any complaints from those individuals. So, I mean, you're not going to be able to consume a highly fermentable fiber without having some gas production. I mean, it's going to be there. It's whether or not we can pick them up, pick that increase up. And so, again, perhaps testing with their usual diets. One of the things, though, that we could possibly help to control for is getting information on how these individuals report at baseline. I think that's really important, because then you would be able to pick up people who are already reporting, for instance, super high symptoms and whether or not you want to include those, that would of course be your decision in your protocol. But getting some good baseline data on individuals, I think, and then maybe you need to stratify them.
And since this will usually be a secondary analysis rather than a primary, it's really hard to design right from the front end, because if you're doing a long-term study on cholesterol or a acute study on satiety, you're kind of stuck with your sample size and your screening based on that, right? So that's a very challenging.
Yes, very challenging.
George, are there other questions that have come in as I've been yakking here?
There's a question about food form and the fact that you mentioned that viscosity is critical, you think, and that I totally agree with that. But one of the most unstandardized procedures in nutrition is viscosity. If you look at the viscosity literature, everybody does it different, and the results are all over the board. Do you have any updated information about that? Is there something that, is there a technique that's just perfect for this now, or what's the status?
So is your question in terms of testing the food product prior to administration? Yeah, that actually is my PhD work. So do I know more than what I learned in my doctoral program? I don't think so. It's a challenge. It's a real challenge. But whatever test you're going to do to test viscosity, at the very least, again, they can make sure that the actual intervention product and the control product that are being tested are at least similar at the point of consumption. And I think that's the best we can do. Yeah. But the difficulty, as you pointed out, is that comparable? Then can we actually compare those between published studies then if we've used different ways of testing viscosity? Right. But very challenging.
Yeah. The last presenter, we talked about rate of fermentation. Is that something that's really important, do you believe, or what's your feeling about that?
Definitely. And I think that's what we see likely with the high tolerance to some of the resistant starches, right, that the actual breakdown is pretty slow. And so of course there is fermentation, and often 100% fermentation with some of these products. But if it's slower, the individual's just not going to notice.
That's right.
And then with oligosaccharides, with some individuals, you're probably getting some fermentation actually even prior to the colon. You may be getting some gas production and terminal ileum, and these are the people that are going to be exhibiting a lot of symptoms.
That's right.
A lot of discomfort.
Right. And you mentioned that about the misconception about a lot of people believe insoluble fibers are not fermentable. Well, insoluble fibers are very fermentable. Some of them are zero, but some of them are very high. Yes. So it's not that simple to just categorize fiber into soluble and insoluble and expect the fermentability to be 0 to 90 plus. That's not the case. Some of the soluble fibers are not very fermentable, frankly.
Exactly. Yeah, and I'm not a super big fan of in vitro fermentation testing, but because I don't think we can, in any way really compare to what's going to happen in the human colon, but at least it gives you a little bit of an idea of the fermentability of it prior to doing a human trial.
Oh yeah. And rate, that's one place where you can get pretty good rate data. In vitro puts you in the ballpark. It kind of ranks things. You don't dare take the numbers as expect them to be transferred to in the in vivo, but it will help you kind of rank and decide on how you want to move forward in vivo. That's right. What I think about in vitro. So I think it's valuable from that standpoint.
Yeah, and one of the things though, with the fermentation, the individual has such a big effect too. Like for instance, if I think about the individuals that participate in our spring study, the individual with the transit time of 21 hours is not going to be fermenting much of anything.
That's right.
And then of course, the people that had transit times of greater than 72 hours are going to have likely complete fermentation of most everything that we give them.
Right. Okay, we're at right on time here to make a change. Thanks so much, Wendy. Great talk.
Thank you, Wendy.
We're going to move on to hear from Dr. Deanne Liska, who's now at Texas A&M. Deanne's been now in academia and has been in industry for years, and so we're anxious to hear her insights on this topic. So Deanne, take it away.
Hi, I'm Deanne Liska, and I'm here to talk about populations and selecting populations for tolerance studies of non-digestible carbohydrates. And currently, this is my disclosure slide. Currently, I'm working with Texas A&M AgriLife on strategic initiatives. More relevant to this is the past 5 years, I've worked at BioFortis Research, and I still consult with BioFortis Research. It's a third-party contract research company for food and supplement companies. And prior to that, I spent about over 15 years with different companies doing a number of tolerance as well as other types of studies. So that's my experience for this talk. And I wanted to start with this slide because it comes from Joanne Slavin's review in 2009. When she did in the review, talked about study design recommendations for tolerance and some of the host factors, which is what we'll talk about. I'm going to actually build on this because she did a wonderful job of putting together a list of factors to consider. And some of the ones that I think more recently there's been more detail on and more discussion around and are relevant to this are health conditions, medications, drugs, supplements, and smoking, and I'll hit on those. But because there's so much to talk about, I will go through some of this pretty quickly so I can spend a little more time on the place where we make the most decisions. So first, the population depends on the study type. And with respect to that, the study type, I've been told that you're going to have or have already spoken about setting safety limits and tolerance studies, and that we're talking about fibers that are already approved for use. So in that sense, there's often studies that are published on safety and tolerance, and they tend to use healthiest, non-reactive, sometimes just men, often just men. And another type of study type is comparing to a product for like better tolerated than X. And in that case, you go to the other side. You go and look for people who are known responders to whatever product you're comparing to. And the general population is actually a spectrum. We have both of those types of individuals. You have healthy, non-responsive to various foods, et cetera, and then you have very highly reactive individuals. So it becomes a much broader population, and that's what I'm going to speak to today. So how do you consider the general population when it's so broad? Well, I think first you want a representative population to how you're going to use your product, how you're going to use your ingredient, because it is exactly that huge, broad population, and you want to exclude and be a little bit specific to try to decrease variability. But the more exclusive you are, the harder it is to generalize. So most studies, you have to talk about age, often don't include children. That's a separate study, and you'll talk about that later. With sex, when you include women who are menstruating, you need to consider that there are bowel habit changes during menstruation and for many women, and some are very inconsistent. So you either exclude those who have really inconsistent, irregular menstruation, or make sure you at least track it. And for some of the short-term studies, you might want to avoid certain days. Ethnicity is a consideration. BMI, often there are no limits. And if there are, sometimes it's a very broad range in order to represent the general population. This isn't an area that people really focus on, one BMI area. I've seen studies go up to less than 40 kilogram per meter squared. And if you do go into that range of obesity, it would be the healthy obese. And so you should at least state healthy obese. But often BMI isn't even listed in terms of an inclusion-exclusion criteria. And in terms of excluding, almost always lactating and pregnant women, and a long list of different diagnosed diseases and such, or individuals with diseases are often excluded. But what's relevant to this general population is chronic disease, because right now, if you say, what's the general population in the US? The CDC will say that 4 out of 10, or 6 out of 10 individuals, adults, have chronic disease, and 4 out of 10 have 2 or more. Most tolerance studies I've seen exclude people on anti-diabetic, cholesterol-lowering protein pump inhibitors, chronic use of anti-inflammatories, antidiarrheals, and laxatives, and anything that would affect GI tract, cholesterol, metabolism, bile acids, etc. The more you exclude, the less it might be generalizable. So this is an area where it's often worth a discussion with your legal, with your regulatory, with others, to actually look at how much can we exclude individuals and still be able to generalize. But it's something you'll need to really specify. Specifically to GI-related studies and to tolerance studies are GI-specific disorders, and colon cancers, history or presence, inflammatory bowel disease, celiacs. Those are individuals who are often excluded. But functional GI disorders is another matter. And you will also hear a little bit more about this in another talk. So I'm not going to go into symptoms, but functional GI disorder, the most common one, irritable bowel syndrome. There are a lot of people who believe they have that, but may not have been clinically diagnosed. Up to 40% of people will be experiencing chronic fluctuating symptoms that are similar to some of the functional GI disorders, or might represent some. Diagnosis criteria differ across different countries and different standards. But if you use the most recent Rome 3 standard, the IBS in the US and globally, it's 1 in 10 people. In the US, it's about 10%. Using broader standards, it could be up to 15 to 20% of individuals. One of the key points about this is that IBS is treated both for GI symptoms as well as biopsychological symptoms. And so this brings up another criteria we need to think about, which is individuals with mood disorders or psychological related disorders. And that's a criteria that you will also often see an exclusion in tolerance studies. Lifestyle, general cover for lifestyle, physical activity, alcohol, but specifically to tolerance studies, I wanted to talk about pre and probiotic supplements, because what I'm seeing more recently, it used to be people would say, exclude individuals on probiotics, but then you have to talk about what about foods that may have had probiotics with them, or yogurts, or different types of foods like that, and it becomes very tricky. What I'm seeing more recently is this definition of pre and probiotic supplements, exclusively to supplements. So anything that's supplemented with pre and probiotic. And digestive related or GI tract related supplements. And with these, you exclude people using them if they're not willing to wash out. And you can allow them to wash out, and I see about 2 to 6 weeks. We often do about 2 to 3 week washout, but depending on the study, you may want a longer washout. Anybody with recent antibiotics, 3 weeks to 3 months is the time of recent antibiotic use that I've seen. So it's a broader range. And I don't know that there's a right week, but usually within 3 weeks as a minimum for antibiotics. And I think you really need to think about the type of study, the amount of product, and the broadness of the population, but also the length of the intervention itself. And I wanted to call it smoking and inflammatory bowel disease because there was just a recent publication, and it was a really nice figure, and I don't have too many diagrams, so this one I'm not going to go through, but just to say that we know smoking has an impact on intestinal epithelium. It's correlated with inflammatory bowel disease. There's an increase of Crohn's disease. There's actually potentially a protective effect with ulcerative colitis. But this means you need to think about smoking and identify, are you going to exclude smokers? Are you going to include smokers that exclude heavy smokers? And that's what often we would do if you want a more generalizable population. You can include smokers that define what designates a heavy smoker and exclude them. It also brings up the issue of marijuana and needing to address that because that's more and more common question, and thinking about that in advance. You can deal with it case by case, but anymore it's something to think about. And CBD supplements, not necessarily in the same as smoking because they're often consumed as a supplement or a gummy or something, but they are often people use CBD for anxiety, and since we just talked about mood, that may be something to consider as an exclusion as well. The more you exclude, the less you may be able to generalize. So again, there's a trade-off on that. With diet and interindividual responses, I think you're also hearing some more about that. So I'm really going to focus on extreme dietary patterns. This is something I see more and more, and it's becoming a standard in tolerance studies, is to really define individuals on a more common or average, as variable as average can be, diet, but avoiding people who are doing something that we would consider extreme. And it used to be, and Joanne Flavin can speak to this because she's done a lot of these studies where she excludes vegetarians, and we used to do that as well. But with so much plant-based foods and plant-based diets today, I'm wondering if we need to define that better in the future. And then I'm going to talk a little more about responders, but are you going to exclude people who you know react to, in particular, inulin and phos, because that's one that people usually know. Or include them. And if you include them, it's good to know if somebody knows that they're sensitive to certain things that are relevant to your product, and then you can do a sensitivity analysis at the end of the study. I was asked to talk a little bit about analysis considerations. So just in terms of that, I suggest defining GI-related adverse events versus tolerance in the protocol. What are tolerance symptoms, and when there's an adverse event that you'd actually report out or designate as an adverse event versus tolerance as an outcome, because that can sometimes be confusing and lead to duplication, but a difficulty in resolving data. And how many subjects is a big question, because past studies haven't always done power calculations, but it's common. Most studies are between 20 to 60. If you're doing healthiest of healthy and really, you exclude a lot of subjects, so you're getting like the males only, et cetera, you might be 10, but that's just for the safety study. For something that's more of a broader population, I'm seeing people doing 40 to 60 or so. For a couple of reasons. You may be able to detect a significant difference in looking at the mean response on a questionnaire. But there's two questions. One is not just, is there an average difference in response? The other is how many subjects actually responded, and how many subjects responded in a way that would be considered problematic to them, so they may not buy that product again, so something that they would call bothersome enough that it would make them change wanting to consume that product again. And that's looking at the data differently, and that's what you might think of as a clinically relevant or a marketing relevant type of approach. And I'm going to show an example of that. You also need to think about subpopulations. If you want some subpopulations, you probably need more subjects. And I will say with subjects too, before I get to this slide, I mentioned antibiotics. In the past, we used to try to wash people out of antibiotics when they had to consume them while they were on the study. What more recently, because it's unclear how long somebody needs to be washed out after an antibiotic regimen, more recently we've just made sure to add a few extra subjects, especially in the wintertime, in case we need to remove those subjects who end up on antibiotics at sensitivity assessments, remove them from our protocol, and just not try to spend extra time, like an extra month or so in the middle of a study washing somebody out because they had to do antibiotics. So I brought this study in as an example. It was published this year, Iriondo and Gahan. It was a study done in Europe. And it was done for sensory and tolerance purposes. So it's not an efficacy trial. It's not a long-term study. It's simply comparing different products with different amounts of inulin. And the inulin's at 0, 3, 7, and 13% in these yogurt products. And the publication, sometimes it's difficult to publish a tolerance only study, especially if it's a single intake, et cetera, is what I'm going to show you the data for here. But they also put in a number of sensory factors and other factors with the product. So technological aspects and such. And 3% represents good source claims. So this was relevant to the product rollout. Single serving crossover, they assessed at 2 and 24 hours after intake. When we do single serve or maybe a few servings, like 2 servings a day or something, sometimes it's good to go 48 hours to know that if you have symptoms, you usually have them within 24 to 48 hours after one serving, and you'd like to see something resolve, but they do get their data at the 24-hour point, and they had a 48-hour washout. And that's fine. I mean, within 12 and 24 hours, if somebody has a response to something like inulin, you should be able to see something at those points. Power calculation, they did. And as I mentioned, you don't always find that, but you're finding it more commonly now. And I think it's very important to consider and explain the subject size and why you came up with that. They used the 0.5 variation in GI symptoms, and you can see the data there. They have a scoring of 1 to 4. 1 is none. Then they have a mild, moderate, and severe, or at least that's my language for it. You'll see on the next slide they use some different language for it, but it's really that type of scoring. They came up with a sample size of 34. They enrolled 46. And why they did 46 versus 34, I'm going to presume it was part of the generalizability, the making sure if you have dropouts, and also the ability to see the % of individuals that react versus those that don't. Because for products that you roll out of this type, you want to know not just what is the average, but how many people actually reacted. You can see who they excluded. It was pretty general, not too, they weren't too tight in their exclusions, and they had 1 withdrawal from GI symptoms. So this is just showing the 2 different approaches, and again, Joanne Slavin's recommendations in her publication actually talked about looking at % of individuals who react, or the absolute number, which you see on the right-hand side here, subject numbers that responded to either none or usual, slightly more, much more, or the more extremely more. And then they have, I'm showing bloating and flatulence because bloating was the highest effect they saw. Flatulence was next year. We're going to talk about outcomes in another talk, so that'll come up then. But in terms of looking at continuous data, they saw no significant reaction or response at 3%, so they said that was well tolerated. 7%, 13%, not so well tolerated. But if you look at the number of individuals, the frequency of response, you see that actually at the 3%, there were a few people that seemed to react to the products with the much more. There were 2 to 3 people who reacted with much more symptoms, and there's slightly more symptoms. And you also see in no inulin that there's people who show a slightly more reaction. When you change foods on people, and we know that we do fluctuate day to day, and some you have mild flatulence some days not, that's background. And so you have to account for that in the analysis. And I usually think of none usual and slightly more as being sort of background or no general response. Whereas if you think about those who are responders, those who are sensitive, then I think of much more and exceptionally more. And you can see that the higher the amount, the more people you get in that category. But you definitely have some, like 1 or 2 responders at the 3% insulin, or inulin, sorry. So last slide is my summary slide on population. I won't read through all this, we can come back to it, but it hits the high points, and it again builds on the work that Joanne did, the work that Hannah's published as well. Hitting those points that demographics, life stage, health, in particular chronic disease, functional GI disorders, and the mood and anxiety and psychiatric disorders, and some of the other points that need to be considered in selecting a population. And in terms of genetics and microbiota, I think we've mentioned, or someone else may have mentioned, that we're getting a lot more information in that area. Right now, we can think of That's, if you're looking at responders versus non-responders, that may be reflective of genetics and microbiota in the future, and we may be able to learn more from that, from that work in terms of best populations to use. And I will be available for some questions, clarifying questions, and thank you for listening.
Okay, thanks so much, Dan. A lot of good information in that talk. There's several questions here for you. The first one is the fact that you described the decisions to make about inclusion-exclusion criteria. And this individual is asking, in the spirit of harmonizing between studies or among studies, what do you recommend is a good balance of who to include as representative of the generally healthy population?
Yeah, I think that we had a lot of discussion before these presentations in terms of just how specific can we get. And I think you can come up with, you know, a very broad age range, not excluding anyone based on BMI for the most part, excluding people with frank disease, as we stated. There's a big question I have, and I'd like feedback on people on statins. More and more people are on statins. You used to exclude it. If you want to compare to previously published data, those individuals were all excluded. So there's some standard criteria like that to compare, but it does come down to the reason for doing the study as well. If you have a product you're rolling out, the population, I think, should represent the population you're targeting. So if this is an ingredient and you want to say it's generalizable across the population, then you do have to take a step back and look at the population differently. But if you have a marketing target, I think that comes into play as well, if you're talking about individual products. So that's where it gets tricky to say this is the one way to do it. But there is sort of a standard list that I kind of put on the last slide that is pretty consistent with previously published data, so that you can compare to previously published data. And I do want to apologize for the quality of the publication. I was trying to find a place in the house that worked, but anyway.
Okay. I could hear most of what you said.
Yeah, good.
I get question number 2 I want to bring to you. First of all, thank you for going back and reading Holly's paper. It's a huge paper, did a ton of work, and I just really appreciate that, because at the time it was really based on sugar alcohols, which I hadn't really thought about, and the fiber, and trying to bring those two together. So I really appreciate highlighting that. And what I'd like to do is point out to all the students or people that it's so good to go between fields. For you to have worked in industry and worked at a clinical research center and now at a university, bringing all those skills together is so helpful for fiber. And I always tell people always bash fiber research and they say it was funded by industry. And I'd say if it wasn't funded by industry, there would be no fiber research out there. Yeah. So it's good to government, universities, and everybody bringing that together. I also totally agree with you that we have to look at where the real world is now. So we do a controlled study, and that tells us something, and those are important studies. But if everybody's a vegetarian, why would we exclude vegetarians? If everybody's smoking, then we exclude them. It's a really tough and I thought you did a great job of saying these are the pluses, but as the population changes, it's really research in the real world that people are very interested in, to see what happens in the real world, which isn't controlled at all. Yeah,
and I do think, so we exclude people with extreme diets, but I think you have to really define that, and in many of your publications, Dren, you've done that. But in the past, it was vegetarians, presuming they ate more plants and more fiber, higher fiber. In a previous NHANES non-published work I did way back, we looked at vegetarians and what they consumed, and that's not clear. And today, in today's world, when people say they're vegetarian, they may be consuming more meat alternatives, but that might not come with higher fiber. So I don't think we need to exclude them anymore, but when you look at when you try to model with what's been published in the past, excluding vegetarians was common. So I think, again, extreme, like you need to really ask, you know, is this person on a very high, we ask people if they're intentionally consuming high fiber foods, you know, if they're intentionally, you know, really going through like a really keto diet or something really, you know, like that. And then you have to ask about people who exclude, you know, gluten per se. I mean, how extensive are they doing that? Are they saying they're doing it, but not really? You know, and that's where you get into, even with IBS. Do they say, well, I kind of have IBS because I've been looking on the internet, and so I've decided I have IBS. You do get a lot of people like that, but they're not diagnosed with IBS. So they are actually part of the general population without a diagnosed disease. So if you want to generalize, you need to know, and you need to document, and you need to be collecting data and describing, you know, who your subjects are. But unless you're looking at, and this is where when people do studies for safety or tolerance, where you're doing much higher fiber intake and you're really trying to find that line, that laxation line, you do exclude a lot of these individuals and get the healthiest of healthy, et cetera. But when you're doing, you know, looking at the general population, I think you need a little bit larger subject number. And the studies are still small. You know, 40 people, you know, if 10% respond to something, or a 5% respond, or 3% respond, I mean, how many subjects are you really going to have responding to it? So you have to think through a lot of those factors in coming up with the right subject numbers.
Yeah, and one of the questions had to do with being clinically significant versus statistically significant.
Right.
Could you talk a little bit about that?
Yeah, and I think of that as looking at, and again, you in the previous publication had mentioned, look at the data two ways. And I think that, you know, that was the point of the example, is the example that I gave, that one study looked at statistically significant and said, well, it's well tolerated because when you look at the total scores and you look at the average, there's no significant difference, right? But then when you look at the individual responses, to me, if you're looking at rolling out a product, well, how many people are going to go from none and mild? Because I think none and mild is sort of that background that we all sort of experience. And, you know, even if you get a little bit of gas or something, maybe that's fine, and that happens, and you still will try a product a second time. But when you go to when you go from none to mild to a what you'd call moderate or severe symptoms after, you know, one serving or a couple servings, that's a marketing significant, and so I think of it as clinically significant. In the sense that that's a decision-making point for an individual. And so I think that you look at the frequency of response and categorize people as responders versus non-responders, that's more the clinically significant. But when we say something's well tolerated, you know, one person out of 100 is going to react to just about anything, you know, or 1 out of 1,000 or something. So, you know, what is well tolerated to roll out a product? And that becomes looking at it, the total score, and being able to look at significant difference with control. So I think you need to look at the data both ways.
Oh, I wanted to ask this one other question. Somebody talked about insoluble versus soluble and different ways of categorizing. Can you say, yeah, insoluble fiber at a certain point is always safe? I mean, I'll listen to you, Deanne, because I think people want that, but I don't think we can generalize to that at all.
Yeah, I think we have to separate safe, and we have to separate adverse event, which relates to safety, from tolerance. So I think in terms, I don't think you can, I think safety relates to much more than the generic broad category of fibers. But the safety, if you're doing this for a safety perspective, then you are looking at a much different type of response or reaction. You know, you're looking at people who actually have diarrhea, people who have an adverse bothersome effect, which is why I do think you need to define what is an adverse event, given that you're capturing the tolerance data. When does that go into, and this comes to a clinical a medically related outcome or a different level of outcome than bothersome. It's bothersome, but it resolves, versus you actually get diarrhea. That's a very different. So that would, to me, would be a safety aspect. And that gets to this definition of tolerance. We have to define tolerance, which we'd love to hear from everybody here on what is the definition of tolerance from you, both of you, actually.
We have several more questions, but we're out of time. So we thank you, Deanne, for that great presentation. And we will then move on to our next speaker, who's Dr. Kristen Verbeke from Leuven in Belgium. So Kristen, it's all yours.
So, good morning. Thank you for the introduction. So, my name is Christine Verbeke, and I'm a professor at the Translational Research Center in Gastrointestinal Disorders at the University of Leuven in Belgium. And today, I would like to talk to you about the different outcomes that you could use when assessing GI tolerance to dietary fiber. So, here you can see my disclosures for the past 2 years. And this is a figure that shows you the burden of GI symptoms in the American population. So about 72,000 people completed the questionnaire for GI symptoms experienced in the past week. And you see that up to 61% had at least one GI symptom in the past week. Heartburn or reflux was the most reported symptom, followed by abdominal pain, and then you had bloating, diarrhea, and constipation. So this is the background of symptoms that we have to take into account when testing tolerance to dietary fiber. There are several parameters that you could use to assess tolerance to dietary fiber, and the choice will depend on the type of study. For instance, if you aim to perform a rather small-scale intervention trial, you may have the opportunity to collect samples from the participants that you can analyze for specific markers. In contrast, in population-based studies with very large numbers of participants, you will likely be limited to participant-reported outcomes like questionnaires. Similarly, if the aim of the study is to decipher mechanisms, you will need to analyze samples to substantiate a hypothesis, whereas again, participant-reported outcomes may be sufficient in observational studies. And finally, also the duration of the intervention impacts on the choice of outcome parameter. After a single administration, you may want to follow up tolerance in a detailed way, for instance, with recordings every hour, but long-term studies may be interested in more average tolerance over longer periods, for instance, 1 week. The most often used tool to assess GI tolerance is a participant-reported outcome and is a GI questionnaire. So here you see the symptoms that are most often used in those questionnaires. So gas or bloating, nausea, vomiting, flatulence, abdominal distension, abdominal pain or cramping, reflux, burping, or borborygmus. There are several options to score the system. You can use Likert scales with different levels. And as an example, I show you here a Likert scale with 4 levels, but you can have Likert scales with 3 levels, with 5 levels, with 7 levels. An alternative option is that you use a VAS score, which gives you a continuous measure instead of different categories. Now, when scoring symptoms, it is important to separately inquire about severity and frequency of the symptoms. At least when you ask about symptoms over a longer period of time, because of course, frequency is not relevant when you ask for symptoms, for instance, every hour after a single administration of dietary fiber. Then I would like to draw your attention to the fact that malabsorption of carbohydrates may also lead to extra GI symptoms. These symptoms have been mainly observed in studies that administer a fructose or lactose dose to patients with functional GI disorders. This is an example of a study with about 2,000 participants, where you can see that up to about 50% reported tiredness after a challenge with fructose or lactose. Also, headache is a frequently reported symptom. These extra GI symptoms seem to cluster together, which suggests that they may have a common mechanism. However, the symptoms did not correlate with gas production. Now, currently, it is not clear whether these symptoms also occur in healthy subjects, for instance, after a challenge with dietary fiber. The most obvious strategy to analyze the results of those questionnaires is to calculate a kind of composite score by summing the score of each individual symptom. So if you questioned 8 symptoms on a score between 1 and 4, the composite score will range between 8 and 32. So in this way, you obtain a single value per participant that you then can subject to statistical analysis. An alternative, and especially when evaluating symptoms at several time points over a day, is to calculate the area under the curve. And then interpretation of the data can be based on statistical significance, although statistically significant differences may not always be relevant. Especially when evaluating large populations, it is possible that you can detect a statistically significant effect that you consider minor and not relevant. A possibility would be then to consider a fiber as well tolerated as long as the symptoms are scored as absent or mild, but not moderate, for example. Another possibility is that you define a threshold in allowable increase in the composite score. And this is what was done in this study here. So in this study, 8 symptoms were scored as non-mild or severe, and intolerance was defined as an increase of more than 2 units over the baseline. So more than 2 units, that means that you allow that 2 symptoms increase from a score non to mild, or from mild to severe, or that 1 symptom could increase from non to severe, but not more than that. The threshold will, of course, depend on the numbers of symptoms that you have scored, and also on the number of Likert levels that you used in your scoring system. Now, when you're using questionnaires, it is also important to know that the participants understand the symptom description. And this study performed in the Netherlands asked the participants to give a description of the symptoms that they had to score. And they concluded that the level of understanding was acceptable, and that the symptom for which participants gave the most incorrect description was regurgitation. Furthermore, they asked participants to rate their symptoms at home, and then again during an interview, both at the beginning and at the end of a study visit. So here you see that the reproducibility of the interview was excellent, but remarkably, the scores were about 37% higher than compared to the scores of the questionnaires completed at home. So based on these data, you could recommend that symptoms are always assessed in the same setting throughout a study. So it can be either during an interview or based on questionnaires at home, but you should not mix it up, because then you can get unreliable results. Now, when talking about tolerance to dietary fiber, also stool habits are relevant. In the 90s, gastroenterologists at the Bristol Royal Infirmary in the UK developed a stool scale to be able to estimate transit in patients, because in gut physiology, transit time is of central importance and was not often measured. So the scale is widely known as the Bristol stool chart. You see it here as an example. And the participants have just to inspect their own stools and to attribute one of the 7 types to them. So far, this score has become the gold standard to assess stool consistency in epidemiological and in clinical studies. The Bristol stool score correlates reasonably well with measurements of whole gut transit times and is even able to pick up changes in transit, as is demonstrated here in this study. So in this study, the participants received either loperamide to slow down the transit or senna extract to fasten the transit. And you see that the changes in whole gut transit correlate quite good with the changes in the Bristol stool form. If you wish, the Bristol stool score can then be complemented with a stool diary that includes a number of questions to score in a similar way as the GI questionnaires. And these questions may then reflect the impact of a specific bowel pattern on well-being. For instance, feelings of incomplete defecations, of having to hurry to reach the toilet in time, are things that you cannot obtain from the Bristol stool score. So these are additional questions that you may be interested in. Now, if we move from participant-reported outcomes to what I call objective measures, so meaning parameters that are measured in samples, the most often used test is probably the hydrogen breath test. The test is based on the principle that human enzymes do not produce hydrogen. So the only source of hydrogen in humans is bacterial metabolism of carbohydrates. Now, it is important to realize that the test has been developed to detect malabsorption of digestible carbohydrates such as lactose and fructose. If you administer these sugars, they should be absorbed in the small intestine. They should not get into contact with microbiota that are largely residing in the large intestine, so you do not expect hydrogen in bread. In case of malabsorption of the sugars, they spill over into the large intestine, get fermented by the microbiota with production of hydrogen. Part of the hydrogen leaves the body via flatus, but part will end up in the systematic circulation and is finally exhaled in breath. So in those tests, breath hydrogen is used as a qualitative outcome. It is yes or it is no. There is malabsorption or there is no malabsorption, but the total amount of hydrogen in breath is not relevant. After administration of a fiber, and especially of a fermentable fiber, we expect by definition to find hydrogen in bread because fiber will not be digested in the small intestine and gets fermented in the large intestine by the microbiota. So in this context, the hydrogen in bread is considered as a kind of approximation of the total intestinal gas production, and assuming that more gas means more complaints and more GI symptoms. So in this way, we use the hydrogen as a quantitative measurement. However, it is important to realize that the relation between the total amount of hydrogen produced in the gut and the fraction of hydrogen that is exhaled in bread is not linear and depends on the rate of fermentation. So at high production rates in the colon, the fraction in bread does not proportionally increase. Furthermore, the correlation between hydrogen in bread and symptoms has mainly been evaluated in the context of sugar malabsorption. So this is a retrospective analysis of about 1,000 lactose malabsorption tests that were performed in our hospital, where you can see that only about 70% of those diagnosed with lactase deficiency and thus lactose malabsorption reported discomfort, whereas also half of the people with a completely normal lactose digestion report discomfort. So here you see that the correlation between discomfort and hydrogen is not very strong. However, within the group of lactase deficient people, those that reported discomfort, so the blue bar in this figure, they exhibit significantly higher hydrogen in bread compared to the ones that do not report discomfort. The stool parameters that were measured with the Bristol stool scale in a participant-reported way can also be measured directly. So stool output can be easily measured, and also stool consistency can be quantified as a percentage of dry weight obtained after drying of the fecal sample. Of course, these measurements require collection of stools and manipulation by laboratory staff, which is often cumbersome and not very pleasant. Transit can be estimated from the position of radio-opaque markers upon X-ray. So in this case, then participants have to swallow several capsules with different types of markers. So as you see here in this figure, you have circular markers, you have tubular markers. They swallow the capsules on different days. And then on the day of the abdominal X-ray, you can see the position of the markers, and then based on that you can calculate a transit time. Now, in addition to those measures for tolerance, one could consider to add also some exploratory outcomes, which might help to better understand why tolerance may differ from one fiber to another. And one of these exploratory outcomes is analysis of the microbiota, to understand the difference in gas production after consumption of different fibers. So the total amount of hydrogen in the gut is the net result of hydrogen production and hydrogen utilization. The major source of hydrogen production is here the conversion of sugars to pyruvate that is then further converted to short-chain fatty acids, and also the conversion of lactate to acetate produces hydrogen. On the other hand, there are three types of reactions in the gut that utilize hydrogen. And the first one is a reduction of sulfate to sulfide. Then we have conversion of hydrogen to methane and conversion of hydrogen to acetate. Some microbial species, mainly belonging to the phylum Firmicutes, or have been identified as high producers of hydrogen. I give you here some examples, whereas other ones, such as, for instance, Akkermansia muciniphylla and Faecalibacterium prosnitzii, or only produce low amounts of hydrogen. And also the hydrogen utilizers are quite well known. The acetogens belong mainly to the Ruminococcus clostridia or Streptococcus. There are only two species that produce methane in the intestine of humans, and sulfate reducers are widely present in the intestinal mucosa. Another exploratory outcome that has been introduced is magnetic resonance imaging, because that allows to quantify the amount of water in the small bowel and the amount of luminary gas. And the technique has mainly been applied to better understand the symptom patterns in IBS patients. So what you can see here is that symptoms in IBS patients after consumption of either glucose, fructose, or inulin are clearly higher than in healthy subjects. Consumption of inulin increases the amount of hydrogen excretion in patients, but to a similar extent as in the healthy controls. Fructose increases the amount of water in the small bowel, also again to a similar extent in patients as in healthy volunteers, and also the amount of colonic gas and the colonic volume was not different between the patient and the controls. So it was concluded that the symptoms in IBS patients may be due to hypersensitivity to the same amount of gas and water compared to healthy controls, rather than to a different handling or processing of the carbohydrates. So, to summarize, I would like to emphasize that, again, that the outcome of choice will depend on the primary aim of the study, but that A good start to assess tolerability is to score the most common GI symptoms based on frequency and severity, and to combine this with the Bristol stool score. If desired, such evaluation can be complemented with measurements in stool, with a hydrogen breath test, with analysis of the microbiota composition, or with MRI analysis. And then you will have a more complete view on the tolerance to dietary fiber. And with that, I would like to thank you for your attention.
Hey, thanks very much, Kristen. Great talk.
Welcome.
Yeah, it was wonderful. As somebody who's tried all of these things, I really appreciate your end where we would love to have stool weights and transit times, but in most studies, it's not very practical. So one of the questions that comes up all the time is, do you need something besides self-report? Can we believe people if they say, I'm having these symptoms, and since a lot of our, like breath hydrogen, a lot of times doesn't really give us an objective measure to check on them. It's basically self-report. How do you feel about that?
I think it is self-reported, but actually that is also, yeah, what the people feel. We cannot say it is not true that you feel too much flatulence. We can say, yeah, although you do not have a lot of gas production, but you still feel it. Yeah, then it is like that. So I think that the additional measures, the objective measures, can help to understand why they feel specific symptoms, and even they do not always correlate, like hydrogen in breath does not always correlate very well with what the participants report. But I don't think we can say that they are wrong if they report symptoms, even, yeah, always understand or explain why they feel the symptoms.
Yeah, and that there were lots of questions along that, do we always need a hydrogen breath test to coordinate with any type of tolerance study just to show that, yeah, this person, but it's exactly what you said. When you look at some of the lactose intolerance studies, there are people that have really bad symptoms, but it doesn't correlate at all with the hydrogen test. So
I would not say that we always have to do it. I think that it is not necessary. It can sometimes help to explain the difference or to compare maybe different fibers within the same subjects. It might help to explain that one fiber indeed gives more hydrogen than another one, but I don't think that the hydrogen breath test is really essential to test tolerance. It tests something else.
yeah, no, that was one of the interesting questions about the people that just said, do we always have to have that? So I think there's this question too, as you move up the ranks and say, well, let's get an MRI, let's get some more objective measures. They haven't really told us much more. Like it would be hard to justify if our interest is just tolerance. It seems like the studies that need to be done are these subjective studies, but in an organized fashion where we kind of agree on those scales. Why do we have it from 1 to 3, 1 to 6, 1 to, it seems like to standardize those subjective scales would be a great way to move this field forward.
Yeah, I agree. I agree that all the fancy, analysis and tools will not give a more objective idea of tolerance. Sometimes it might help, and like the study that I showed in the IBS patients showed that it is not the gas and the water and the volume, but that it is something else. So it can maybe also help in fiber studies, but I think it is not an indication of tolerability. It can help to explain why something is well tolerated and when something else is less tolerated.
Dr. Fahey, any other questions that have come in that we should get to?
There's a question about the hydrogen breath testing and its applicability to fibers for tolerance. You know, it's a bit of a controversial subject. Not everyone, there's some people believe it's not very useful. What would be your response to that?
I think that if you want to do it as a measure of tolerance, it does not correlate well enough with symptoms to use it as a measure of tolerance. I only would say if you would like to know why a specific fiber is less tolerated than what you would have expected, you could try to do a hydrogen breath test to see maybe it gives unexpectedly large volumes of gas production, something like that. I think that it can only help to explain symptoms, and even that is not always the case, but I would not use it as an alternative for a questionnaire. It can be added to a questionnaire, but not an alternative of a questionnaire.
Yeah, I always find too that it's confusing because you really have to use it acutely. You know, like breath hydrogen is going to vary throughout the day. So if the people are eating other fiber, other things in their diet, we can't link it to. So it really has to be on a fasted person. And then you look at breath hydrogen based on that. And then they have to eat lunch and something. So we can't go past 4 hours really. That's as long as we're going to have for that measurement.
That's it.
Let's see. I think that's all the questions we have. Anything else, Joanne, on your end?
I have a question about the Bristol stool chart. As somebody who's graded lots of exams and lots of stools, I think it's a good idea, but it really doesn't. Most people are gonna, like everything in humans, they're gonna go towards the middle. So you don't usually get one, you know, like if you look at it, that the average, if I give some people some fiber, most likely it's not going to move the needle on the Bristol stools chart. So, if we're talking about normal subjects here, not people with disease, I think it's worth collecting, but I don't think people should expect to see a lot of significant changes with an average dose. Wendy had talked about the dose of 15 grams a day. I would be really surprised that most fibers at 15 grams a day are going to move the needle on the Bristol stool chart.
Yeah, well, it is not that sensitive in the sense it has 7 categories. Normal people have somewhere between 3 and 4, and maybe you can go to 5, or it can shift a little bit, but you should not expect too big changes. But I think that is also not what you would like to have that fiber does. I mean,
how come the transit time is so highly correlated? If it's I learned you told us that I wasn't aware of that. That's a
it has a correlation about 0.7, which is not too bad.
Yeah, no.
Not at all. It has been developed actually as a tool to estimate transit in patients without having to really measure it as an indication of transit. And it seems to correlate reasonably well. Yeah.
I would say, George, it goes back to Dr. Dahl's point too, that person that had a transit time less than 1 day, that's diarrhea. I can tell you what that's going to look like, as opposed to the 3-day people. They're going to be on the other side. So yes. I would expect it to probably correlate pretty well with the measurements that are there.
Indeed, those evaluations have been done mainly in patients where you have a broad scale. If you only have people that vary between 3 and 4, I'm not sure whether then the correlation will be that good. Right. The correlations are most often done in patients with a good range where you have all kind of transits.
Okay, great. Okay, thanks so much, Kristen. Really appreciate your contribution here. So this is the time we have for a break. And during the break, we'll be resetting the system, so I understand, and we'll reconvene at 12:30 p.m. Eastern Time. Welcome back, everybody, from your break. I hope you had a good one. We're moving to our last presenter in this session. And let me remind you that we will continue to use the question box to promote dialogue. So write your questions in that box. The last speaker today is Dr. Bruno Ciampatazzi. He's a clinician in a pediatric setting, and he'll provide a perspective on GI tolerance from that particular angle, specifically with children. So thank you, Bruno, for participating, and we look forward to your talk.
Good afternoon, everyone, and thank you for that kind introduction. It's a pleasure to be with everyone here, and thank you to the meeting organizers for the opportunity to present on special considerations for gastrointestinal tolerance testing in children. These are my disclosures related to both grants and royalties. And this is the outline of the talk that we're hoping to go through today. First, we'll be talking about some salient childhood differences as compared to adults in terms of nutritional requirements, cognitive development, and gastrointestinal physiology as it may relate to starch malabsorption and usage. Second, we'll go into abdominal pain in the childhood population and touch on functional gastrointestinal disorders. And finally, we'll be going into some child-friendly, non-invasive assessments that can be made both of symptoms as well as GI physiology when doing evaluations in children. Now, with respect to recommended dietary fiber intake, the amount that is recommended is based on the age of the child. What you're seeing here on the left and the right are for boys and girls respectively, the amounts of dietary fiber which are recommended in terms of grams of fiber per day, from 0 to 40 here on the y-axis for the boys, and from 0 to 35 for the girls. As you can see here, based on the age of the child, there is an overall increase in the amount that's recommended, both if you use the age plus 5 grams per day paradigm here in the dark bars, or the age plus 10 grams per day in the slightly lighter brownish bars. And there's a general increase here both for the boys and the girls that can be seen. This line here is representative of the AAP, or American Academy of Pediatrics, recommendation of 0.5 grams per kilo up to 35 grams per day. And again, as can be expected, as the child is getting older, there's a general increase in the amount of recommended dietary fiber. Now, if one were to take a look at the amount of dietary fiber that Americans take based on the NHANES data, you can see that children, similar to adults, do not do a very good job. Here on the y-axis, you're seeing the daily dietary fiber amounts in grams per day. The dark bars represent the actual amounts of intake, and the slightly lighter bars here are the daily recommended intakes amounts for both males as well as females. In the childhood, age groups are highlighted here from ages 2 all the way to 19 in these 3 categories, both for males and females respectively. And as you can see, there is a significant gap here between the amount of intake and the daily recommended intake in the childhood age groups. What I would like to point out, however, is that the gap is not nearly as large for children as compared to adult males, where you can see that the amount that's required to meet the daily recommended intake is significantly larger as compared to boys. However, in comparison, when one is looking at females, the gaps are actually in adolescence and early childhood somewhat similar to the gaps required for adult females. So it's important to keep that in mind when we're talking about designing trials for both boys and girls in children. As for developmental considerations, Piaget, who was a Swiss psychologist, has a cognitive developmental stage paradigm which has permeated pediatrics for many years. And there's 4 different stages that are described that you can see here. Children who are in the ages from 0 to 2 are in the sensory motor stage cognitively, and they're developing and using their 5 senses and actually starting to develop memory. In the ages 2 to 7, this is described as the pre-operational stage. Children are now starting to engage in pretend play and understand symbols such as words and numbers as representing other entities. These 2 age groups and cognitive developmental stages are probably not appropriate in terms of asking complex questions related to gastrointestinal symptoms, particularly if they may be somewhat abstract, such as touching base on bloating. However, once you reach the age of 7 to 11, in which you hit more concrete operational thinking, in which you're now able to think logically about objects and events, such as, for example, abdominal pain, or in children who are greater than 12, where you now hit the formal operational stage in which you're able to think hypothetically, these 2 age groups are more likely to be able to answer questions related to GI tolerance testing in a more logical and appropriate way. When we talk about children, we also need to talk about differences related to the fact that they have ongoing developing GI physiology. This can be very important when we talk about carbohydrate digestion, just as, for example, lactose it's very uncommon for children to have lactose malabsorption until approximately the age of 6, in which there can now then start being a change towards the adult hypolactasia phenotype. Adults, as we all know, unfortunately end up having lactose intolerance lactose malabsorption approximately 70% of the time worldwide. Fructose is another carbohydrate in which there's a change based on age, in which there seems to be a relative decrease in the ability to decrease fructose, which is worse at the age of 2 to 3, and then slowly but surely starts improving over time to the point where it starts reaching the adult type ability to absorb fructose. Other changes in GI physiology which may impact how certain fibers may actually play a role in a child can actually relate to defecation frequency, which varies by age. And this is a table here which describes the normal frequency of bowel movements that one can see in children, ranging from infants 0 to 3 months, infants 6 to 12 months, getting into the toddler years of 1 to 3 years, and then in children more than 3 years of age. What you're seeing here are the range of normal in terms of the bowel movements per week that one can expect, and then on the average bowel movements per day that can be seen. So as you can see, young infants, particularly those who are breastfed, can have a significant number of bowel movements per week, all the way up to 40 per week, and that would be within the normal range. At the same time, children who are formula fed will also have a frequent number of bowel movements, but it really starts to slow down, as can be seen over time here. By the time children reach 1 to 3 years of age, they're having anywhere from 4 to 21 bowel movements per week. And finally, once they're older, 3 or older, they hit, as I mentioned before, more of the adult type of picture. So this is important to keep in mind when one is actually doing evaluations of how often someone is having bowel movements, particularly when evaluating tolerance testing in children. We need to keep in mind that depending on how one defines constipation, for example, having less than 3 bowel movements per week, there's a prevalence of approximately 12.9% in children. And on the opposite extreme, diarrhea can occur in 4.7%. These issues of constipation and diarrhea can relate to GI transit and can affect the physiological manner in which the colon is affected by dietary fiber. Another aspect which is quite important as it relates to GI physiology in children is the gut microbiome. What you're seeing here is a schematic taking a look at different ages, the unborn, the baby, toddlers, adults, and then the elderly, as it relates to their overall composition of the gut microbiome. If you're taking a look at one of these circles, you can see the different colors as represented here, for example, in the pink and the light blue. And those represent different types of phyla of the bacteria, including Firmicutes and Bacteroidetes, etc. As you can see, there are differences between healthy babies versus toddlers versus adults that can be seen. So there's clearly a transition that's occurring over time, often thought to be related to the different things that are being eaten in the diet. There are even changes that occur in the elderly period, though we will not be touching base about that. It used to be thought that once you're older than the age of 3, that you will then develop more of an adult type of picture. But as we've been learning by more recent publications, including that by Hollister et al., there actually are differences between toddlers versus pre-adolescents, and differences between pre-adolescents and adolescents before they get to adulthood. And so there are significant differences in gut microbiome composition depending on the age of the population in children. There are also differences based on dietary intake in children. What you're seeing here is a publication from 2010 by Di Filippo et al., comparing children here on the left side from Burkina Faso versus the gut microbiome composition in children from the European Union, actually from the Florence, Italy area. And what you can see here based on these color schematics are that there are significant differences in composition, with the children from Burkina Faso having a lot of this green color here, which corresponds to the Bacteroidetes. Whereas those children from the EU have a significant amount of this reddish color, which corresponds to Firmicutes. And it's thought that this is related to the fact that the children from Burkina Faso have a lot of intake of vegetables and legumes and cereals, which comprise the majority of their diet. In comparison, the children from the European Union have significant amounts of animal protein in which they're eating, and very little of the other types of foods. And clearly, there are significant differences. So it's thought that the actual baseline dietary composition of the children actually plays a role in terms of the gut microbiome that is found. Now, earlier in this conference, you've also been hearing about GI symptoms that can be found in the population, and this also occurs in children. There are disease entities known as childhood functional abdominal pain disorders, which are really highly prevalent. And these are defined as disorders in which abdominal pain occurs at least 4 times a month for over 2 months. And there's not an organic reason for the pain. What that means is that the pediatrician, when evaluating a child for this abdominal pain, cannot find a problem such as an ulcer or an infection or some other cause for the pain. As I mentioned before, there's a high prevalence in the United States. It's estimated to be about 13% of the population, and about 8.4% of the childhood population worldwide has these issues. As was presented earlier in this conference, this can be important because the pathophysiology related to these disorders, for example, having visceral hypersensitivity, which means that even small stimuli for some reason can cause discomfort or pain, can increase the sensitivity to malabsorbed carbohydrates and fibers such as inulin. As if one were to try to evaluate not just functional GI disorders within the population, but just abdominal pain, one can also see that there's a spectrum between identifying children with chronic abdominal pain versus healthy controls. And this can be seen by validation of a tool which was known as the Abdominal Pain Index, which evaluated the amount of abdominal pain frequency, intensity, and duration over the past 2 weeks. In this publication from 2015, the group took a look at scores by age and sex and group in children, with this top group here, FAP, being the functional abdominal pain group. The range of the scores were from 0 to 4, which was the maximum value. And you can see that, as expected, in children with chronic abdominal pain, there were certainly means significantly above 0 or even 1. But perhaps what is perhaps somewhat surprising is that even in healthy controls, children who are absolutely healthy and do not complain of any chronic GI symptoms, when they complete this abdominal pain index, those children who are in childhood, early adolescence, and late adolescence, you can see that there is a baseline score or mean that's above 0 in the general population. And in fact, in some children, it can range from 0 to 4, which is actually the highest score you can actually have. So there are certainly some children who I like to say may actually even have quote unquote occult abdominal pain, which is not reaching the point of them seeking a medical care or even having it affect them in any way. But they are having abdominal pain, and this is something to keep in mind when having evaluations of GI tolerance in children. Previously, we heard about the PROMIS scales that can be used when evaluating symptoms, and this can also be done using child-friendly questionnaires. There's specifically a PROMIS pediatric pain interference scale, which is a self-report scale used by children 8 to 17 years, and it's very short. It actually only comprises 8 items, and it relates to the last 7 days. And so this can be used in trials. There's the Pediatric Quality of Life Index, which is a very child-friendly, health-related quality of life measure. There are the abilities of children to self-report and also parent proxy forms, which is to say that parents can actually complete the scales on behalf of their children for these age regions here. And now more recently, there's actually a GI symptom module, which has 76 items and 11 domains, which can be quite interesting when considering evaluation of GI tolerance in children. And if you take a look at just some of the domains here on the left, stomach pain and stomach upset, based on cognitive and focus group interviews, there were a lot of themes that were able to be gathered when it comes to identifying GI symptoms. And these items are distilled in a very child-friendly way, so that when asking the child, for example, they're being asked to rate things such as I feel pain or hurt in my stomach, or I get stomach aches. And the type of language that's used is based on the age of the child, and so that they can actually understand it and be able to rate it in a reliable way. What's important is that there are additional domains of interest related to GI tolerance testing, including constipation, diarrhea, flatulence, and bloating. And the domains can actually be used individually. One does not actually need to use the entire scale. So this type of evaluation, which is child-friendly, can certainly be considered for GI tolerance testing in children. There are also other assessments which are child-friendly. We've heard about the Bristol Stool Form Scale for adults. There is a modified Bristol Stool Form Scale for children, which eliminates 2 of the categories in order to make it more cognitively able to be completed by children themselves. And this was shown to be a valid tool in children as young as 6 years of age. And if you were to do studies in infants, there's even an infant stool scale, which takes a look at the amount and consistency and color of stool. And as you can see here, it actually does it in the context of a diaper. So these are for children who have not yet been toilet trained. Moving on to non-invasive assessments of GI physiology within some of the studies that you may be considering. There are ways of looking at whole gut transit, including carmine red, which is a very child-friendly, non-absorbed material, which is easily swallowed and visually seen in the sense that it actually colors the stool red when it comes out. Some of the disadvantages are that it's important to identify an accurate date and time of the carmine red ingestion and when the defecated red stool. And that can actually be a little bit more of a challenge than one can imagine. So therefore, at times, it's required to actually collect the stools and be able to document and increase the rigor of the study by also visually seeing the stools from a study personnel basis. As was previously mentioned in the conference, there are also radiopaque markers that can be used. The advantages are that they're non-absorbed and easily swallowed, and they're seen on radiographs. And there have actually been pediatric-friendly modifications such that instead of using radiographs of the abdomen of the child, there can be radiographs completed on the defecated stools themselves that are captured. Now, some disadvantages are that if one is obtaining radiographs of the child, that it would increase radiation exposure. And second, that if one is doing transit time calculations, it may actually require multiple marker swallows, for example, on 3 consecutive days and subsequent radiographs. So it can start becoming a little complicated. Breath hydrogen testing was mentioned earlier in this conference, and we will not go into that, but there are also ability to do this in children, as is the wireless capsule, which is a smart pill, which can measure pressure, pH, and temperature. Advantages that it does not include radiation. Disadvantages are that it's a relatively large capsule, but can be used in children who are over 8. It requires the carrying of a recording device around the child for several days, and it's not quite Food and Drug Administration approved for children. In terms of non-invasive physiologic assessments, gut immune activation can be evaluated by looking at proteins that are secreted into the GI lumen. These proteins actually pass into the stool, and they can be somewhat resilient to being broken down. And depending on what aspect of GI physiology you're interested in, either it being neutrophils or innate immunity or enteroendocrine cells, one can actually take a look at some of the proteins that are listed here. There can also be an assessment of the leakiness of the intestinal lining. The epithelial lining is a semi-permeable barrier that absorbs certain things and allows certain nutrients to be transported across, but needs to prevent entry of harmful substances or pathogens such as infectious bacteria. And one can, in children, use sugar probes, which allow for one to evaluate the magnitude of the permeation of these sugars through the gut mucosa. And what happens is that the child actually drinks a solution, which may include these carbohydrates here, such as sucrose, lactulose, mannitol, and sucralose. And then over time, via the collection of urine, can actually tell how much came across the GI tract into the body itself. And finally, in terms of non-invasive assessments, the intraluminal environment can be assessed, again, using the wireless capsule, which was previously mentioned, or for example, using fecal samples to take a look at gut microbiota and metabolites. And using bioinformatics, as was heard earlier in this conference, one can take a look at the different types of bacteria that are found, the different types of metabolites, and actually relate them to the responsiveness or non-responsiveness of a subject to different fibers or foods. So final take-home points. Children are a unique population with age-based nutritional requirements, cognitive developmental stages, and gastrointestinal physiology that may impact their ability to have GI tolerance to certain foods. Abdominal pain occurs in a large subset of children, with approximately 15% having functional abdominal pain disorders, and we also talked about a high prevalence of constipation and diarrhea. And finally, there are a lot of non-invasive assessments that are available for children when evaluating GI tolerance, including GI-friendly symptom questionnaires, child-friendly stool form assessments, and non-invasive physiologic assessments as well. With that, I'd like to thank several investigators who I've worked with over the years, including those at the Children's Nutrition Research Center, the Texas Children's Microbiome Center, the Baylor College of Medicine Metagenomics and Microbiome Research Center, as well as the research support that is listed here. Thank you very much for your attention.
Thank you, Bruno. Appreciate the good information. So now we have a few minutes to for some clarifying questions for Bruno. And let me see here. My control panel has been compromised, I think, but something finally came on. So let me just give me a second here.
Sure. While you're looking, thanks again for the opportunity to present. This has been a wonderful conference, and I've learned a tremendous amount. So I'm really looking forward to the discussion here and with the panel.
Well, we learned a lot from you. That's a really interesting topic. So let me see here now. Okay. Joanne, why don't you look at these questions?
There's one question. Really enjoyed your talk. I got to say, as somebody who's worked on everything as far as the dyes, the radiopaque pellets, the smart pill, there are tools out there, but they're quite difficult, especially in healthy children. So, you know, to me, once you get into a disease population, parents would be more likely to want to do anything that has any risk at all. So even like the dye, like that's been used forever and it works really well, but most parents, when we worked with children, parents are like, no, you're not, why would I? And even human subject committees, I think, are pretty risk averse now for, if we're just looking at tolerance in a healthy population, do you see issues with getting permission to do those studies? Just to find out if fibers are going to affect tolerance. It seems like not a very important question to put somebody at any risk at all. The SMART pill is huge. I mean, our subjects couldn't even get it down. It is, and obviously if it's not approved by the FDA for kids, it's kind of off the table in my book.
Yeah, those are really good questions. I think most of my experience, so I'll just caveat my response with that, is that most of my research is in children with irritable bowel syndrome, and not as much in children who are healthy controls. So we've had success with getting the IRB, and perhaps our institutional review board is more lax for whatever reason here at Baylor College of Medicine than in other locations, but they've been receptive to us using these child-friendly measures. In terms of looking at healthy controls, we do have a little bit of experience looking at things such as the Carmine Red evaluations in that group, and we've not had a lot of pushback from the IRBs in terms of trying to use that. Perhaps we really coach it well enough in the sense that we really feel like it's safe, it's inert, and comes through without harming them. Some of the disadvantages I listed, though, you're right. Some parents are just, they're no longer in the bathroom with these kids after a certain age. So we're really dependent on the child, the maturity of the child, how invested they are in terms of actually identifying when the stool comes out. And that's why I mentioned, if you really want to try to be very rigorous, you probably need to collect the stool, which I think you mentioned earlier is not the easiest thing to do. You don't need to do these assessments in terms of evaluating GI tolerance. I think the goal with some of the ones I mentioned towards the end of the talk was really to try to get a sense of the GI physiology if you're interested. We've had a lot of good success with GI microbiome collections, which tend to be cross-sectional, but in any case, sorry, I'll stop there.
That is one of the questions that came up too. How do you feel about in children the microbiome and the relationship to GI tolerance? Do we have data there? Would it be better to just measure the microbiome? Are people more interested in doing that? One sample, you don't have to collect longer. So that's one of the questions the participant or the people put up on the website here.
Sure. So there is a lot of interest in initial assessments of the gut microbiome composition and determining whether or not someone with irritable bowel syndrome, including children, may actually benefit from certain restrictive diets. So there's actually a type of diet known as the FODMAP diet, which is fermentable oligosaccharides, disaccharides, monosaccharides, and polyols. So it contains a lot of the fermentable substrates that we've been talking about in this conference. And there are some data and groups that people have been putting together that try to take a look at the gut microbiome before even going on that type of diet to see if it can predict whether or not it will be helpful. In children with IBS, we're starting to see signals where, yes, that you may actually be able to predict whether or not you would benefit from starting to restrict certain foods. And we just came out with a paper that was published online yesterday looking at children with IBS and seeing that those children who were sensitive to fructans or inulin seem to have a different gut microbiome composition as compared to those children with IBS who didn't really seem to get an increase in symptoms. So I think the data is growing out there, Dr. Slavin, but we still have a little ways to go, particularly in otherwise healthy children.
And do you feel like, I've noticed the FODMAPs haven't come up, so since you started it, I will jump on here, that generally, a low FODMAP diet takes fiber out of the diet. So it's kind of going in the wrong direction, and for a lot of people, they have success with low FODMAP diets by taking fiber out of their diet. How do we kind of bring those fields together and, yeah.
Yeah, I think you've just laid out the next couple of years of research to try to figure that out. We just completed an evaluation of dietary quality and nutrient intake in children in an ongoing randomized control trial. And these children, one arm of the children are undergoing the low FODMAP diet in which they're restricting everything for a few weeks. And with the help of a dietitian, and I think that's going to be the key, we actually did not see a decrease in dietary fiber. We saw an increase in insoluble fiber intake. So more to come with that. We only had 29 children in the arm, and we submitted the abstract to Digestive Disease Week for May. So we'll see if it garners any interest. But I think with the right teaching and coaching, you may be able to avoid decreasing dietary fiber content. But there are studies in adults that say that unfortunately dietary fiber intake does decrease.
Right, and I think it's really important data, so I'm glad that you're working on it. And because a lot of the questions we've had during this session too is insoluble going to be tolerated better, fermentable, viscous, all these questions that are remaining. And to bring together the low FODMAP diet and the importance of increasing fiber and more plant food for overall health, really important. So, George, are there other questions that you have taken off here?
One is about what ages should be utilized for children's studies. Do you consider stratification best to control for variation? Did we cover
We didn't
that?
get there at all. No, please answer.
Yeah.
I'll do my best, but Dr. Slavin, I might look to you to help. In terms of trying to compare apples to apples, if you are going to rely, say, for example, on the child, him or herself actually answering the questions from a GI tolerance standpoint, you may start asking or start around the age of 7 or 8 and above. If you're going to be using proxy measures, i.e. the parent is actually going to try to respond to some of those, you can certainly go down lower, but keep in mind that there are significant differences in bowel movement frequency up until the age of about 3 or so. And so my bias would be, but I'm certainly open to input, would be to consider, 3 and up if you're going to go with proxy measures, and maybe 7 to 8 and above if you're going to rely on self-report.
Okay, great.
Yeah.
Great.
I would like to really appreciate that people are doing, because one of the questions I always get when I talk about fiber is constipation in kids. And so I think a lot of that has to do with just the change in frequency between a toddler, once a day after, like you pointed out, that's what you're expecting. And somehow parents think that's abnormal. It's like, no, that's fine. So it's good.
Okay, we're a little past our time to start with the general discussion. So thank you a lot, Bruno, for your contribution. And so if we could have everybody now, all the speakers, to come online here, we'll get started with our general discussion. And here we all are. That happened, that's fast. Well, our objective here is to pull together some of the key themes and learnings that we've experienced this morning. And we also would ask the audience to chime in here with the chat, with the question box, to give their comments. And but first, we'll hear a little bit from Dr. Slavin. You have a few comments to kick this off, since we haven't let you talk near enough. So we want to hear more. So
well, that's nice of you to say. I really appreciate that. I've gotten as much airtime as I have. I've been in fiber forever, and it's still my base business. I love it, and it's so nice to see younger people coming into the fiber world. I felt like everybody was a geriatric, so it's really nice to see interest across. So I really appreciate all the speakers that we had. Also, I like the concept that we're actually have one topic here that we're working on, which is tolerance. And I don't see why we can't say tolerance is important enough that it could be our primary objective. So often we want to add it on, and my whole life it's always been an add-on. Every study we do, people are like, hey, why don't you add that on? There is one study, Angie Bonema, one of my students did, that was the whole thing was set up just to look at tolerance. And it's probably the clearest study I have ever done and to show differences. So I really appreciate that the focus here is on tolerance and to go after it in a sequential way of let's think about, you know, and for my speaker, all the speakers here, I appreciate that you stayed within your lane too, because it's really hard not to expand all through. So it's been great to give this idea of tolerance. I do a couple of comments, just that bringing the data together from the sugar alcohols. There's a lot of data, and that's what Holly Grabitsky, my student long ago, said. You know, they do these studies in a certain way. They're all acute studies. They're basically dosing studies. They're basically tox studies. They're done not like nutrition studies. So if we're going to look at some of these acute effects of fiber, I see no reason why those studies wouldn't be the same. And they could be fairly simple studies with this as an endpoint. This is really important in a normal population, that when we want people to eat more fibers, if certain fibers are tolerated much more just better, but they still have the beneficial physiological effects of fiber, those are the ones we want to put into products, put into drinks. So this to me is a great step forward. So just appreciate everybody coming to this, and I'm looking forward to this publication where you have inputs from everybody. You know, and as we go through here, some of the simplest things of, should we have a standard dose? Should we have a standard? Appreciate, you know, the questions about dose. Should the subjects be in normal subjects and then any type of disease state? We really have to think of that as separate, because that tends to get together. Are we going to give it in a certain way? And is subjective really the important thing here? Is if I take in a fiber and at 15 grams, I don't have any symptoms, then that's fine. Even though my breath hydrogen skyrockets, if it doesn't affect my symptoms, in a normal person, that is where we need to be. So great discussion on that, and I appreciate everybody chiming in. I also want to just point out that I tell my students all the time, go to industry, go to the government, go to academia, and bring all those skills together. It's great to have some of my other dietitians and clinicians here. So all these people, getting people to work together with different skill sets, because sure, the stakeholders discussion that Hannah talked about is, you know, the consumer is a stakeholder, physicians are a stakeholder, food companies, all these people are stakeholders. And for ILSI to get involved in this fiber symposium really helps to bring all those people together. So I appreciate your sponsorship too.
Great, thank you. So the first question here is for the panel discussion: does a well-designed clinical study for tolerance have to have a dose response? Or should this be based on the DV levels for good or excellent? Then there's the point about kilocalories. Therefore, what is really the best way to pick doses for fiber? So let's have, let's say, Wendy, you want to try that one? Then we'll pick on somebody else after you.
Well, I don't think it has to have a dose response. I think what I would recommend is that it would have at the very least, well, maybe the two doses at say 3 and 6 would be enough. I don't think it has to have the higher dose, but often if tolerance is the secondary outcome, often those studies need to have that higher dose. And so those longer term studies, so you're going to actually end up getting tolerance to multiple servings a day.
Okay. Deanne, what do you think?
I think at the lower level, with what you're going to put as, say, a good source, often there are very few symptoms. And you don't have to have a dose response, but it's easier to interpret a study and to be able to talk about the data if you actually have some level where you have symptoms. So I think having what we call positive control, or a high level of intake, you know, that anchors on one end, so the positive and the negative, just the studies are a lot easier to interpret that way, to show that you really didn't have an effect, especially because you are talking subjective symptoms. So you don't have to have it, but it will be more convincing if you have a positive control.
Okay, good response. Kristen or Hannah, Any additional comments?
Not really. Thank
Not
you.
really. Okay, Hannah, for you or Bruno?
No, I would echo what my colleague said. Again, it can be very useful to have the doses, and then certainly those positive and negative controls may need to be considered to answer your primary hypothesis and your primary objectives, and then secondary, and then those considerations again may be iterative if tolerance is that primary, to make sure that you can, finish the study in the way that you proposed.
Okay, good. So another question here, do you think consuming raw foods like vegetables versus cooked equivalent affects the gut microbiota?
I think that's an interesting question. I'm not sure how to consider it to fit within the context of this tolerance session, but Dr. Dahl definitely alluded to food form, and we are aware that certain fibers, depending on their matrix and the cooking preparation, may influence that tolerance. So I'm not sure if we want to frame it in that context. I'm not sure. Wendy, did anything to add from that perspective, considering cooking, for example, for fibers?
Well, starch digestion is the main thing that's going to be very different between cooked food versus raw food, if they're starchy foods, because you're going to get a lot more starch resistant to digestion with uncooked. If you have the overnight oats versus the cooked oats, for instance.
Mm-hmm.
Okay.
And we did discuss briefly, Dr. Verbecki brought in some of the conversations around, the microbiota could be a potential novel exploratory outcome that could help you to better understand those tolerance outcomes, because again, the cross-feeding of microbes, that interspecies hydrogen transfer, methane production, for example. So I'm not sure if you want to add any of that to the conversation, Kristen.
Yes, I think that if you change the structure of the fiber, you will change the digestibility, and I think also the fermentability, and that might affect the microbiota. I would not be surprised that I'm not aware of studies that really compared the same food raw and cooked, but I would not be surprised that it would affect the microbiota composition.
I agree. Anybody else have a thought on that one?
I would like to just point out that, the study we did with the 2 different doses of fructooligosaccharides and then 2 different chain lengths, there were significant differences with shorter chain versus longer chain. And there's really very little research, this whole thing of cooking versus raw, tons of interest on the consumer side, but really very little research. I think all of the new data too on fermented foods and how does that affect the gut microbiome and how does that affect tolerance, just lots of areas that need exploration. And obviously the whole gut brain idea of a lot of these tolerance problems, we have such individual variability among our subjects in their tolerance. So bringing those things together, there's so many different mechanisms that we get excited about, but I do want to bring us back to this idea that can we come up with a standardized method for a fiber manufacturer to say, hey, I want to make sure that tolerance of my product is good in an average person, and this idea of who would we compare it to for our negative control and our positive control. These are really important questions that a paper like this should get after.
Yeah. This one's for you, Bruno. It says you're not sure exactly what the pathophysiological effects of IBS itself is. How are you sure that FODMAPs is the cause? Or rather that symptoms elicited is a manifestation of IBS organic disease itself? Does that make sense?
Thank you. I think so. Let me do the best I can. So irritable bowel syndrome is a multifactorial process. We didn't go into it too much, and we did talk about the concept of visceral hypersensitivity, and that happens in a subgroup. About 1/3 of the adults and children or so have that problem. But there are other things. There have been abnormalities in the gut microbiome, abnormalities in psychosocial distress, whether it be, and I think we've heard a little bit about the brain-gut axis, whether it be depression or anxiety, or a phenomenon known as somatic symptoms, in which there can be overlap with headaches and other things that can play a role. And one individual, unfortunately, which makes it a little bit tough sometimes, but one individual can have more of an abnormality in one factor as compared to another, which makes it difficult. But in terms of trying to find out if FODMAPs actually worsen symptoms, we don't usually think about it as causing symptoms. We think for the most part, if somebody has irritable bowel syndrome, that underlying biology is already there. But it would actually usually be, if you really want a gold standard, would be, as we're hearing here with the fiber aspects in terms of assessing tolerance, would be to do a positive or negative controlled study. In our laboratory, we often do randomized crossover trials in children with irritable bowel syndrome to determine whether or not the increase in symptoms is really specific to a particular FODMAP before we label them as being FODMAP sensitive. But that can be challenging to do in the real world. So often in the real world, it's having, taking the conscious time to actually challenge yourself, say over a couple of days, to see whether a certain food may or may not elicit symptoms.
Okay, great. Anybody else want to weigh in on the FODMAP issue? Doesn't look like it. There's
chicken. No, I wouldn't weigh in just because I think the problem is it puts all these things in a box or like in a gamish, and that what makes it hard. For right now, we want to use fiber combinations because we want to make it closer to real foods. But to find out about are certain fibers more problems for gastrointestinal tolerance, we have to feed those alone, and whether we need 2 or 3 doses. But once we have this mixture in the FODMAP, is it the sugar alcohols? Is it different fibers? Are certain fibers much worse? I think it gets lost in the discussion, and it's not really fair to the whole category, which is basically higher fiber foods are going to be your FODMAP problems. I think it's, as dietitians, since we can't really find out exactly how these FODMAPs are measured, it's hard to translate it back into grams of fiber or grams of sugar alcohol.
Yeah. There's a question that kind of leads into what you said about someone asked about the food that's used to deliver the fiber, and it gets down to the ingredient versus the fiber, how you're going to handle this tolerability. For example, like wheat bran. Okay, wheat bran's a fiber. Well, yeah, it is. It has about 43% TDF, and it has everything else, something else. Okay, but yet wheat bran is the gold standard, as we heard. So how do you handle that type of thing when you're talking tolerability? Is it the tolerability to the wheat bran, or is it the tolerability to just the fiber piece? I mean, you really can't separate that out. Hannah, you want to?
Yeah, I guess I would propose that ultimately, begin with the end in mind. What is our translational relevance of this? If we're testing a food product, then the incorporation of that ingredient in the form that it's going to be available to consumers may be the most appropriate. If it's a very specific scientific question where we're looking at the mechanisms and food matrix, we may need to dive deeper and be able to separate out those pieces to hone in on the specific mechanism. But ultimately, I think it depends on the question. And if we're thinking about tolerance and moving it to the consumers, a simple approach of that ingredient within the food matrix that's tested with, in a randomized double-blind placebo-controlled trial, if we can, with the appropriate positive and negative controls, is an appropriate manner to consider.
Okay. What do you think, Deanne?
Yeah, I agree with that. I think we also need to document better what is used. I mean, that's common issue across a lot of areas of nutrition that's being dealt with, and and even in like herbals and others, and needing to have better documentation of what's used. And if you want to look across a category, like wheat bran isn't one thing. This is where I think with a tolerance study, having more than one, either more than one intervention, they're usually not control and intervention if it's just about tolerance. Usually you have 4 or 5, different test products and in an acute study. So when you're doing the acute tolerance studies, you can do that. And you could have some different types of wheat bran preparations. And another issue gets, when you have like inulin and fructose oligosaccharides that are shorter versus longer, you're going to have differences there as well. So if you're looking at a category like that, you probably need a couple representative types of ingredients that you can differentiate in some way, but also to be very clear about defining those ingredients in more detail than just wheat bran.
Yeah. Good points. Anybody else have an opinion on that one?
Well, I think we have to continue to point out that fiber is a nutrient of concern. So we are only getting about half as much as we need. And even though consumers think that it's only fiber in food that's important, the only way we're going to get fiber up to its recommended level is supplemental fiber. So that's why, to me, testing these fibers in a fair environment to just show how well they're tolerated is a really important endpoint for both consumers and food processors to make a product that's going to be, has the benefits of fiber. So these are fibers that have been approved by the FDA, and are they well tolerated? So if I put enough in to make it an excellent source of fiber, the average consumer is not going to have GI problems, because that will make them not ever buy the product again, and fiber intake will continue to slide.
That's the second time you've been a great lead in to the next question. Next question is, since higher doses of fiber closer to 50 grams per day may need to achieve more reliable health effects, why would a fiber dose of 15 grams per day be the focus of tolerance studies? Wouldn't higher doses be more valuable for closing the fiber gap? 50 is a lot of fiber. Who was, let's see, was that Kristen, or who talked about that? Who suggested the 15?
Wendy.
Yeah, okay.
Yeah, that was me.
I'll put you on the spot.
Well, 50 would definitely put all of us over the recommended average intake.
Yes.
Adding 15 grams across the board really would get the population up to the range that we would want them to be in. So like typical average intake of adults in the US is what, about 17, 18 grams a day. So you add 15 to that. Yeah, so it's reasonable. 15 grams increase per day is a reasonable goal.
Yeah.
And I would just echo there. I mean, when that AI was set, right, Dr. Slavin, I've seen her present on those data, and there's a reason that, 14 grams per 1,000 kcals based on the cholesterol outcome. So, and again, certainly maybe that research is developing, but AI is that 25 to 38, right? So 50 would be a little high. It doesn't mean it wouldn't help further facilitate additional health benefits, but would certainly depend on the type of fiber, right? 50 grams of inulin is very different than 50 grams of polydextrose, for example.
Yeah.
And I think that's the advantage of having these protocols, that you use a certain amount just to make it fair to the system. And I agree with Deanne that if you don't give enough, you're not going to see anything. The average person can, a lot of these resistant starches, you can get 80 grams into people and they don't really have any problems. So 15 is the fiber gap. So I think it's a good number to definitely test.
Yeah, I would like to add that normally you will also not eat 50 grams of a single type of fiber and not at one intake. So if you mix up different types and fermentable with non-fermentable and soluble with not soluble, it will also have much impact on the tolerability. And you do not have to test every single fiber in a dose up to 50 grams, I would say.
Right. I always remember a conversation I had with our good friend and fiber specialist, Dennis Gordon. Dennis was working on a fiber. I don't know if he's part of the group here today, but he was working on a fiber, and he was telling me that he was eating 90 grams every day of this fiber and just getting along great. As he slipped into the toilet. No, I just kidding. We have another question here on microbiota. Microbiota changes are physiological changes associated with fibers, but is it a primary priority indicator of GI tolerance? And if specifically, what is the microbiota measure to indicate intolerance? Kristen, you want to try that one?
I don't think that the microbiota can be a primary outcome when assessing tolerance.
Yeah.
You can use the microbiota and analyze the microbiota to understand tolerance, but as such, it does not, I would say, it does not replace assessment of tolerance. And you cannot say, I mean, instead of assessing tolerance, I will analyze the microbiota composition and then draw conclusions on tolerance of the fiber. I don't think that will work like that.
Right, right. Anybody else have an opinion on that one?
I think in an earlier call, Hannah had some comments on microbiota and differences in people who, you know, when you look at responders and non-responders in some cases. And so we had talked about how this is an area to watch because it's not something we can necessarily select people on or understand today. But one of the emerging areas is whether in the future you'll be able to see, you know, look at microbiota and predict maybe responders versus non-responders. And I think, I don't know, Hannah, if you remember that conversation and some of the data you were talking about on that, but it's an emerging area.
I completely agree, right? I'm that's where I live, right? Diet microbiome, health studies. So agree it's an area of interest, but we'll certainly echo what Kristen said is that, you know, that's not a primary outcome, but it can be used as an exploratory, especially when we consider the mechanisms, you know, cross-feeding but you know, we've also presented some interesting data in this session where we talk about, let's use lactose malabsorption versus lactose intolerance as an example, right? The breath hydrogen levels could be through the roof in individuals that are maldigesters, but they report absolutely no symptoms. Rather, on the other end of the spectrum, you could be lactose intolerant, but have very little lactose maldigestion with those breath hydrogen as an example. So again, certainly, if your budget can allow it and you have the scientific expertise to incorporate it, we would encourage it. Maybe that even includes biobanking when you're collecting those stool samples, but not as a primary outcome. And then I just asked, I don't know if Bruno had anything else to add. I believe you mentioned the microbiota and IBS as some exploratory measures you were doing in your kids in that recent paper.
Yes, you hit it on the head. Actually, very, very similar terminology that's being used in IBS in terms of responder versus non-responder and how that can be used to try to predict. I like how you use the term mechanism, right? And we're trying to understand why it is that there may be some differences between them. Hydrogen is showing that fermentation is occurring, and we're understanding that, but that's not the whole story, right? We're understanding that these carbohydrates are hitting the colon and naturally they're going to start getting fermented. Is there something else in terms of how either the gut microbiome is responding in terms of population, or as I alluded to really briefly in the talk, in terms of the metabolites, right? What is it actually producing that may give us some insight into that? We heard a lot about short chain fatty acids and other things during the conference, which are really exciting, but could there be other things, right, that could actually be causing the symptoms that we're just not picking up just yet?
Well, I think we could go on for quite a while, but it's 12:30 and my sheet tells me that we're supposed to adjourn. I want to thank all of you speakers. You did a fantastic job. This is a great session. Thanks to Joanne for all of her input. And I'll turn it back to Barbara Lyle now to close us out.
Thank you. Again, introducing myself, I'm Barbara Lyle. I work with a carbohydrate committee at ILSI that has planned the content of this symposium. And what I'm going to do in the next 5 minutes, I'm going to multitask here and share my screen while I'm doing this. So hang on for 1 second. What I'm going to do in the next 5 minutes is 3 things. Number one is I'm going to very briefly highlight some of the key points made in the symposium. Number two is I'm going to show you the next steps that will follow from this symposium. And number three, I'm going to reveal a surprise that is on my last slide. So stay tuned. We will be through this in about 5 minutes. My first slide is to show my disclosures. You can read them on the slide. The only one that relates primarily to fiber and carbohydrates is my role as a consultant, as a senior nutrition advisor to the ILSI North America Carbohydrate Committee. I'm going to sneak in my thank yous. So I didn't list that in my 3 things, but I'm going to sneak this in. You can read it on the slide. Again, I'm not going to read slides to you. The Carbohydrate Committee and a working group of it, including George Vahouny and David Klurfeld, were the brains behind the plans. And then we went into execution with each of the speakers separately. So a thank you to all of those. A thank you to Susan Cho, who is the person that over the past few years has been organizing this virtual symposium. Among the ILSI staff and consultants, I particularly want to note Wendelin Jones, who's the executive director, and she stepped in with several staff changes and other things going on to be the head of all logistics on this. So thank you, Wendelin. I want to thank all the speaker chairs, the speakers themselves, and all the moderators. And I want to thank you as participants for being a part of this and actively engaging and not just being in listen mode. So my very brief highlights are on the screen. I am not going to read them to you. I am simply going to make a couple of notes. The first is that I think it was a very interesting discussion about the fact that while fiber has affected many health outcomes, including several like immunity and brain-gut access that were discussed during this seminar, it is not classically defined by any set of deficiency disease symptoms. And that's what makes fiber so interesting as well as complex. If you looked at the FDA's presentation, a very top line summary of that is that the agency for defining fiber relies on publicly available data showing, importantly, it must be an independent effective fiber in a generally healthy population for a sufficient duration and relative to a specific health benefit and not just a physiologic change. We also heard about normal gut permeability as being a measure of fiber health benefit, and particularly we saw a recommended standardized approach for measuring that and for establishing a normal distribution of healthy gut permeability. Next, we learned a lot about the digestive system being the largest immune organ in the body, and also the presenter shared information about the fact that there are ways to design human studies focused on health benefits, like their anti-pathogenic response or antibody response, and also highlighted the fact that it can't be generalized, that fibers really are have their effect on these kinds of immune outcomes depending on the chemistry. In the gut-brain axis discussion, we learned about the term psychobiotics, which was characterized and defined as targeting the microbiome for mental health benefits. I assume that meant the gut microbiome in the context we were discussing here and not other biomes on the body. And again, there was discussion about the benefits for fiber emerging, but not yet delivering on its potential. We had a series of innovation briefs in which we learned new information about health outcomes, about new fibers, and about a new method for measuring non-digestible carbohydrates. Moving to the second day, we learned a lot about the a fiber database tool that's publicly available. It's annually updated, and it's available on both the ILSI website as well as the AHRQ Systematic Review Depository. And I would refer you to the ILSI website for easy access to find that, and to the investigators if you have questions about it. And finally, we closed out with a very robust discussion about whether or not and how we could develop a harmonized research protocol that would inform decision-making on the amount of non-digestible carbohydrates that could be tolerated in foods consumed by consumers. And towards the end, Joanne made an important remark, which was that there's an important role for studies specifically designed as a primary outcome to test tolerance. Though we also recognize that many efficacy or even safety studies could include tolerance testing as secondary outcomes. We discussed the intervention and control products, the dose response relationship, and how that can inform beyond just a single dose. We talked about things like the right balance of inclusion-exclusion criteria for the population to be tested in. Talked about the clinical relevance from the individual perspective as opposed to some measures that maybe are quantitative but perhaps less clinically relevant to the consumer. And we even talked about the GI tolerance uniqueness from both a cognitive as well as physiologically different developmental stages when you're looking at kids. So that is my highlight in very few minutes of the symposium. So I'll move now to my second topic, which is what's next. So the first important thing is that today you will be receiving a symposium evaluation survey that will take less than 5 minutes of your time. It will help us develop programs that best match your needs, and it will also be the way you request CEU credits if you want to get them. So number one, if you don't see it today, look in your junk mail. Second, the presentation videos, with only 2 exceptions, will be posted very shortly after this meeting. We're targeting before December 21st for any of you who attended it. It will go for public viewing later in the year. The standardized protocol for evaluating digestive tolerance intentionally was discussed at this meeting so that the feedback from attendees could be incorporated by the presenters as co-authors of a publication, and that's intended to be submitted for a manuscript in the next few months. And many of you may be wondering, what's the timing for the next Vahouny Fiber Symposium? And I will just tell you that it is to be determined when there's better information on ongoing travel restrictions. So if you were at this meeting, you can assume that your email will be shared with the organizers of the next meeting so that you can receive a notice. And finally, that takes me to my surprise on the last slide, which is our session was opened by David Klurfeld, who gave us a nice history of both of Vahouny Symposium, Dr. Vahouny, and also his relationship with those individuals. And he has been involved in Vahouny from beginning to end. And so it's appropriate that today we end with a virtual toast to David Klurfeld on his upcoming retirement from USDA. And with that, I will close this symposium.